Hello, fellow sapiens. Dim the lights if you can. Let your shoulders soften. Breathe in, slow and even. Breathe out, a little longer. This is a calm, evidence-first walk through deep time, unhurried, precise, and honest about what we know and what we don't. If this kind of slow storytelling helps you sleep or keeps you company on a long drive, consider tapping like and subscribe. Tell me in the comments when and how you listen. Timestamps for each part are in the description. Now, let's begin. Cold open microcene dawn comes thin and peach-colored over a frost-silvered plain. Your breath is a small cloud, a private signal in the still air. At your feet, ground that looks ordinary until you crouch, until your eyes adjust from horizon distances to a nearer scale of clues, glints of chert, a fleck of ochre, the curve of a rib long since turned to stone. A meadowlark calls once and then waits. You reach to the scatter, thumb roughened by hundreds of similar mornings, and touch a sliver whose edge answers with a dry whisper. It is freshly broken only in human memory. In its own time, it has slept for thousands of winters just under the grass. You clear a little circle with a stiff brush. A bevel emerges, then a shoulder. Another sweep, careful. The sun finds the stone and wakes a faint translucence. What looked like a shard becomes a design. A leaf-shaped form, broad near the base, narrowing to a keen tip that still stings your finger when you test it without thinking. Along the center line, running up from the base like the keel of a boat, there is a channel, shallow, straight, purposeful. This is the flute. You don't say anything for a moment, because gratitude prefers quiet. Someone, 13,000 years ago, stood where you're kneeling now, or a day's walk from here, or many days, and held a nodule of high-quality stone. They struck one face, then the other, trimming, thinning, mapping the future in careful removals. When the time came, they set up a risky, elegant act, removing a long flake from the base to open a channel that would thin the point and help it fit snugly into a haft. Too shallow, and the effort is wasted. Too deep, and the point snaps and the hours are lost. It is a decision made with breath held, wrists relaxed, and a kind of memory that lives in hands. You cradle the artifact in your palm, and you can feel, even through gloves, the logic of its shape. The base is ground smooth, so the sinew lashings would not be cut. The edges are straight where they need to be, convex where they guide penetration. The flute is clean and true, as if a bell note had passed through the stone and left a channel of silence behind. You are aware of a kind of humility that comes only when skill meets time. This isn't a miracle, it's a craft, not a relic, but a tool, shaped to do work in a world of cold mornings and large animals with their own plans. In the field notebook, you write what matters first: coordinates, layer, association. No heroic language, just the scaffolding that lets meaning stand. A small scatter of flakes lies close by, some with platform remnants that match the stone of the point. That suggests on-site maintenance, maybe a quick resharpening after a hunt. You flag the spot with a thin rod and allow yourself one sweep of the eyes across the prairie, to the creek line that bends like a thought at the fin or edge, to the low rise where bison would funnel when the wind shifts, to the cut bank where layers tell time in colors of silt and sand. When the team gathers, the conversation is gentle, almost whispered, as if raising voices might shake the context loose. Someone mentions the overlying ash lens that, if we're lucky, will take radiocarbon well from charred plant bits trapped within it. Another person reminds everyone of the bone fragments further upslope, with spiral fractures and percussion marks, signs of marrow extraction, but warns against assuming they belong to this point until the stratigraphy says so. You photograph, you bag, you breathe, and the quiet of early light returns. In the lab months later, this same point will sit under a microscope. Along the edges, polish and microchipping may tell of thrusts into meat and the gritty slide against hide. In a clean room, a swab might test for ancient proteins, traces so faint that they are almost stories rather than residues. If anything is recovered, it will be reported with careful hedges, compared to controls, and framed as possible rather than proven. We will hold the line between enthusiasm and certainty, because that line is where trust lives. For now, on the ground, with frost melting into dark specks on your sleeves, a question rises and settles like your breath. Was this technology, the fluted spear point we call Clovis, the first broad horizon that ties the Americas together, a kind of shared solution spreading fast across a changing continent? Or is it one luminous tradition among several, preceded by people whose tools leave subtler signatures in caves, on coasts, and in places where water has taken the old floors away? We will walk that question across sites and seasons, through models and countermodels, listening for the difference between legend and pattern. The lark calls again. You stand, slower now, as if not to disturb the long conversation under your boots. We'll ask what first means, and whether stone can answer it. We'll ask what a flute is good for, beyond being beautiful. And we'll ask how dates become sequences, how sequences become stories, and how stories avoid becoming myths. In the next part, we'll define what archaeologists mean by a technological horizon, and why words matter as much as stones. Let's take a quiet step back from the frost and the field flag, and put careful words around what we're actually talking about. Archaeology can feel like poetry at dawn and accounting by noon, and both are necessary. When we call Clovis a technological horizon, we're trying to capture a pattern in space and time where a particular way of making and using tools appears broadly, recognizably, and within a relatively tight window. Not a single culture with a capital C, not a single people or language. Rather, a suite of technological choices that show up across many places at once, and then, in archaeological terms, disappear or transform. Technological points us to behavior at the stone, sinew, and wood scale. Think of choices a craftsperson makes. Which raw materials to carry, how to prepare a core, how to strike flakes, how to thin a point, how to grind a base so it won't cut binding, how to seat that base into a foreshaft so the whole system flies true and can be repaired far from the quarry. Horizon asks us to look sideways, not only down the layers. It invites a map, sites spread from the west to the southeast, from the high plains to the mid-Atlantic, where similar points, leaf-shaped, lanceolate, fluted from the base, turn up with enough family resemblance that we can say, carefully, these belong together in a technological sense. Why not call it a culture? Because technologies can travel faster and farther than languages, kinship systems, or sacred stories. A clever hafting trick can be learned across groups who otherwise remain distinct. A striking platform preparation can jump rivers even when marriage rules do not. Culture is wide. Technology here is precise. That precision protects us from unintentional overreach. Archaeologists sometimes use other words that shade this idea. Tradition often signals persistence through time. Industry anchors us in a particular set of techniques. Techno-complex is a way to admit that the package includes more than one tool and more than one method. Clovis, with its fluted points, bifacial knives, occasional osseous tools, and certain distinctive flaking strategies, including, in some regions, dramatic overshot thinning, can be discussed with any of these terms. Horizon, though, keeps our attention on spread and simultaneity, a recognizable toolkit appearing broadly within a bounded time. Bounded, however, is not the same as razor sharp. Dates in deep time come with error bars, calibrations, and contexts that need to be honored. When people say Clovis is about 13,000 years BP, they're pointing to a mid-range estimate, BP meaning before present, with present conventionally set at 1950 for radiocarbon purposes. Calibrated ranges shift the numbers slightly because atmospheric carbon has not been constant. In plain language, we are talking about the last centuries of the Pleistocene, a world of shrinking ice, changing coastlines, and big movements of water and wind. Within that world, Clovis-like technology blossoms across much of North America for what seems to be a few centuries to several, depending on region and model. We'll spend later parts on the dating itself. For now, hold the idea that horizons are about patterns that are tight enough to be meaningful and loose enough to be real. A horizon is visible in more than one kind of evidence. Lithics, the stone tools, are the anchor, because stone keeps its shape and carries decisions very well. But context matters. Where do we find the points? In camps with hearths and discarded flakes? In kill sites with butchered bones? In caches where a craftsperson hid or stored a set of blanks for later? A true horizon speaks across these contexts. Similar points used in varied ways, hinting at a shared solution for hunting and mobility in landscapes that were both rich and risky. Shared solutions do not require shared origins. Technology can converge. Two communities facing similar materials and tasks can arrive at similar forms. But the particulars of Clovis, base fluting from one or both faces, consistent basal grinding, overall symmetry, and the broader package of bifacial thinning, suggest something stronger than coincidence. Apprenticeship leaves fingerprints. When you teach someone to set up a flute removal, how to prepare the nipple, how to support the piece, how to press at the right angle, you pass on a choreography of hands that is hard to reinvent identically in many places at once without connection. Connection can mean a lot of things. It might be people moving long distances, carrying points and stories. It might be short-range exchanges across many boundaries, a relay of useful ideas. It might be the periodic coalescing of groups at known places to share mates, news, raw materials, and techniques. A horizon usually implies some combination of these. The map of Clovis raw material movement, how often a point made of distant chert or obsidian shows up hundreds of kilometers from its source, will help us think this through in a later part. There is also the danger of the word first. Horizons invite superlatives, and for a long time in North American archaeology, Clovis was treated as the first clear, continent-wide signature of human presence, the opening chapter. That tidy picture fit the datasets and dating tools available at mid-century. As methods improved and older sites were proposed and sometimes confirmed, the picture complicated. It turns out the story of peopling likely has earlier pages, some written in caves and rock shelters, others on drowned coastlines now miles offshore, still others in small scatters that only careful stratigraphy can tease from slope wash and animal disturbance. A horizon can be widespread without being the beginning of everything. Holding both truths, breadth and non-primacy, is part of the discipline. Let's also notice that technology is nested in environment. The late Ice Age offered a menu of game and a set of constraints: ice masses, meltwater lakes, seasonal bottlenecks that would reward portable, maintainable hunting systems. A fluted hafted point mounted on a foreshaft that could be replaced quickly after impact is a good answer in such a world. So is a learning system that teaches the risky step of fluting well enough that failure stays tolerable. Technologies that travel are often the ones that save time under stress. Finally, horizons end, not with a single date or a single cause, but with transformation. In some regions, what follows Clovis looks like a close cousin, Folsom, with deeper fluting and narrower, exquisitely thinned points. Elsewhere, regional lanceolate forms carry forward without fluting. In still other places, people choose different answers entirely as environments, prey, and social ties shift. The end of a horizon is not a disappearance, but a branching. So, when we say Clovis as a technological horizon, we're committing to a careful, humble frame. We will track the spread of a way of making and using points that appears across much of North America within a few centuries near the end of the Pleistocene. We will avoid equating a tool with a people. We will distinguish the shape of stone from the shape of identity, even as we admit that hands teach hands and that knowledge has lineages. And we will keep the word first on probation, useful in some contexts, misleading in others, until the dates, the layers, and the models have earned it. In the next part, we'll take up the popular story that Clovis marks the first Americans, and sift myth from evidence with as little heat and as much light as we can. Let's hold the word first in one hand and lay out the evidence in the other. For much of the 20th century, North American archaeology told a tidy story. Clovis points appeared across the continent roughly 13,000 years before present. Soon after, megafauna declined. Therefore, Clovis people were the first Americans, their technology marking humanity's arrival. It was an elegant hypothesis, easy to remember, and, crucially, matched the strongest, cleanest early datasets. Abundant Clovis points in secure contexts, and a then-young radiocarbon toolset that resolved little older. Tidy stories tend to persist until new methods and new sites ask better questions. The first cracks appeared where they often do, in stubborn places and patient measurements. A few rock shelters and caves yielded artifacts below Clovis-bearing layers, separated by intact sediments. The contexts were not always perfect, and early critics were right to demand more. Better stratigraphic control, clearer associations, cleaner dating. Over time, those demands were met at multiple localities. Each site alone could be argued with. Together they began to sound like a chord. Consider a handful. In the far south of Chile, Monteverde offered waterlogged, well-preserved materials, wooden stakes, plant remains, stone tools, dated to a time older than the classic Clovis window. In the American Southeast, Page Ladson in Florida's Osceola River recorded butchery marks on mastodon bone and associated artifacts in stratified, submerged contexts also older than Clovis. In the Great Basin, coprolites, ancient feces, from Oregon's Paisley Caves preserved DNA and yielded dates that, after careful contamination controls, suggested human presence earlier than 13,000 BP. In the interior Northwest, Cooper's Ferry in Idaho presented stratified lithics with dates similarly predating Clovis. And on the southern plains in Texas, large, well-excavated localities like Galt and nearby Deborah L. Friedkin, Buttermilk Creek, contributed assemblages that many researchers interpret as pre-Clovis, though debate continues over the precise readings of their laminar deposits and dating models. None of these sites alone answers everything. Each has its critics and its careful defenders, but the pattern has grown. Multiple lines of evidence across distant regions indicate a human presence in the Americas before the canonical Clovis horizon. That presence does not erase Clovis, it reframes it. Rather than a first footprint, Clovis looks more like a technology that spread widely during a particular climatic and social moment. Impressive in reach and coherence, but not primordial. What made the old Clovis first story so compelling? It fit the available data, and it had a strong material signature. Clovis points are distinctive. You can hold one and feel the design language in your palm. Pre-Clovis technologies, if they were oriented more toward expedient flake tools, coastal adaptations with perishable components, or small assemblages in caves, would leave subtler traces, especially along shorelines now drowned by post-glacial sea level rise. An absence of obvious points was mistaken for an absence of people. When the ocean takes your camp floors and the later wind takes your hearth ash, it's hard to argue for priority in a courtroom of stone. Improved dating has mattered. Radiocarbon calibration curves grew more refined. Bayesian modeling allowed archaeologists to integrate multiple dates with stratigraphic order, essentially asking, given these layers and these measurements, what is the most probable sequence and its uncertainty? This has tightened some pre-Clovis chronologies and clarified which claims are robust and which remain provisional. Methods have matured in other ways too. Micromorphology, which reads soil structure thin slice by thin slice to distinguish intact floors from mixed sediments. Ancient protein and DNA work on residues and coprolites with stricter contamination protocols, and high-resolution mapping that keeps provenience precise to centimeters. Each advance does not decide the debate by itself, but together they build the scaffolding that holds older occupation claims up to the light. There are still minority positions. Some scholars remain unconvinced by particular pre-Clovis sites, pointing to potential mixing, bioturbation, or ambiguous stone flaking that could be natural rather than cultural. Skepticism is healthy. It pushes for better field methods, clearer reporting, and replication, but the center of gravity has shifted. A cautious consensus now holds that people were present before the classic Clovis window, likely by at least a few centuries and in some scenarios more. How much more, and by which routes, remains open, and we'll come to those uncertainties later with the respect they deserve. Part of the myth's persistence also came from narrative comfort. Firstness is a strong word. It gives a story a clean beginning, yet human history rarely offers single doors. Peopling tends to look like braided streams, multiple pulses, pauses, and pathways, rather than one dramatic crossing and a single technological answer. When we call Clovis a horizon, we're honoring what the artifacts actually show, a broad, rapid spread of a particular solutioned, not the dawn of humanity on a continent. It's also important to disentangle technological spread from population identity. A flute on a point tells us something about learning, craft, and perhaps organizational logic in hunting. It does not, by itself, define language, ceremony, or kinship. The Clovis people of old textbooks dissolve under scrutiny into many communities who shared certain manufacturing choices for a time, and then diverged as environments and social networks shifted. If we translate the myth into an evidence-based phrasing, it might be, during a specific late Pleistocene interval, many groups across North America adopted a fluted point hunting system that became archaeologically visible everywhere at once. Before that interval, other groups were already present, using technologies that have been harder to see and are now, thanks to better methods, coming into view. One more careful note. Some striking claims point far earlier still, into the tens of thousands of years. A few bones with marks interpreted as butchery, a set of footprints bound in lake sediments, or very early radiocarbon determinations on tiny fragments have made headlines. These possibilities are exciting, and several are under active, rigorous retesting with independent lines of evidence. For our purpose tonight, we will keep them in the promising but not yet consensus box, acknowledging both their potential and the need for converging methods, secure stratigraphy, multiple dating techniques, and replicated analyses to carry them from headline to history. So, where does this leave the listener trying to sort the legend from the ledger? With a calmer, richer picture. Clovis is not a starting gun. It is a flare, bright, widespread, informative, revealing a moment when skill, material, and environment met and traveled. Before the flare, there was night, yes, but not emptiness. People were already learning landscapes, leaving light prints that our newer tools are better at detecting. After the flare, the light did not go out. It refracted into regional traditions, some fluted, some not, all adapted to changing ice, water, and game. You can release the word first now. Let it float off like breath in cold air. What we keep is the beauty of the points, the discipline of the dates, and a discipline-wide commitment to let the ground, slowly and carefully, revise our metaphors. In the next part, we'll step into the world itself at 13,000 BP, ice margins, meltwater corridors, grasslands, and coasts, to see the landscapes that made a horizon possible. Dim the lights a touch further, and picture the continent not as a map on paper, but as air, water, ice, and grass in motion. 13,000 years before present. Remember, present for radiocarbon work is set at 1950. The late Pleistocene was loosening its grip, but had not let go. Two great ice bodies still shouldered their way across the north, the Laurentide to the east and center, the Cordilleran draped over the mountains of the far west. Between them, depending on the exact moment and model, a corridor opened and narrowed like a lung, part river valley, part glacial outwash, part patchwork of steppe and wet ground. To the west of that, the Pacific Rim offered kelp forests, rocky headlands, river mouths, and, at times, generous low shelves now drowned, where ancient shorelines curled like old stitches beneath today's waves. Sea level sat lower than it does now, dozens of meters down, a figure that shifts with the curve one uses and the moment one chooses. What matters for our purposes is that coastal plains were broader, estuaries longer, and the mouths of rivers began their journeys where modern boats today would still chart deep soundings. The continental shelf, in places, was not a blue distance but a walkable expanse of dunes, lagoons, marshes, and beaches. If people favored the coast, much of their early architecture of camps and paths lies out there now under silt, eelgrass, and tide. Inland, the middle latitudes held what ecologists call a mammoth steppe grassland mosaic, though the details braided differently by region. Imagine tall grass and short grass in shifting patches, with sage and forbs, and ribbons of riparian woodland anchoring valley bottoms. Bison antiquus, larger than modern bison, moved in numbers that practiced their own arithmetic of grass and water. Columbian mammoths wandered where open country met water and scattered trees. Mastodons preferred woodier, wetter places, and held on longest in the east and Great Lakes margins. There were horses on these plains, native to North America. There were camels too, and in mixed habitats, deer, pronghorn, elk, and the Pleistocene predators that shadowed them, lions, dire wolves, short-faced bears, and the quieter specialists we know from bone and tooth. To the far northeast and upper Midwest, the land pulsed with meltwater. Proglacial lakes as large as inland seas gathered at the ice margins, Agassiz and Ojibwe among them, changing outlines as outlets opened and closed. Shorelines rose and fell like careful breath as isostatic rebound lifted some margins even while melt filled the basins. Outwash plains spread pebbles and sand in broad fans. Braided rivers wandered, split and rejoined, leaving bars bright in the sun, a geography that rewards a portable, repairable toolkit and knowledge of seasonal crossings. Further south and east, the forests were on the march, but not yet where you find them now. In parts of the southeast, pine and oak made open woodlands. In the mid-Atlantic, a patchwork of mixed hardwoods and clearing was common. In Florida, lower sea levels exposed wide springs and sinkhole systems that drew game and people alike, leaving deposits now studied by divers in the tannic quiet. Along the Appalachians, cool-loving taxa lingered in elevation refuges, while lower slopes welcomed species expanding north. The eastern mastodon story lives here, in swamps and low-lying margins, thickets of willow and alder, peat and pond, places where a cautious hunter would learn to read muck and hummock, and where stone points could vanish beneath a season's leaves. Across the interior west, the Great Basin hosted both pluvial lakes and broad dry playas depending on the local hydrology and timing. Imagine basins with standing water, shorelines scalloped by wave action, and fish in numbers that would make a camp smoke smell like wealth. Then imagine, a few centuries later or earlier, wind-crossing white flats and small springs you could cover with your jacket. Landscapes here asked for memory and for networks. Knowledge of where a reliable water pocket sits behind a basalt outcrop, or how a line of mountains casts afternoon shade over a seep rich in game tracks. Climate at this time was not a static backdrop. We are close to the onset of the Younger Dryas, a sudden return to colder conditions that begins around 12.9 thousand years ago by many records. Whether you stand exactly before that threshold or with one foot on it depends on the site and the calibration, but the main point holds. Variability mattered. Year-to-year changes in snowpack, stream flow, and growing seasons would have rearranged the travel plans of animals and people alike. When we imagine hunters with fluted points, we should picture them not only in a grand open plain, but also in a world of shifting baselines. Routes learned and then revised, lakes dependable and then fickle, winter lines drawn and redrawn on the land. Raw materials tell their own map of this world. Good stone, fine-grained cherts, chalcedones, jaspers, petrified wood, quartzites, and volcanic glasses like obsidian occurs in specific beds, seams, float cobble bars, and uplifted ridges. A fluted point found on the plains may carry the signature of a quarry 200 kilometers distant. In the southwest and basin range, obsidian sources are nearly as distinct as fingerprints, thanks to their trace element chemistry. Bifaces made from it can be tracked across valleys and over ranges, indicating either people who moved far or people who met others who moved far. Both are plausible. Both probably happened. The animal calendar set rhythms. In the open country, bison followed the grass. Pronghorn timed fawning to the wave of spring green. Birds traced continents on invisible highways. Salmon ran in rivers west and north. A point meant for a large mammal hafted into a foreshaft that could break away on impact is a clever answer in this world. If the main shaft survives, and the foreshaft can be replaced from a small stock of spares, you can keep hunting without rebuilding the whole system. The flute, by thinning the base, helps that join be secure without bulking the binding. The edge can be resharpened many times, changing the point's silhouette from wide to narrow as it lives its working life. What about the famous corridor between the ice sheets? At 13,000 BP, parts of that passage were viable in some reconstructions. Ice-free, dotted with lakes, supporting steppe tundra and then shrub tundra communities as plants colonized newly exposed soils. Other reconstructions emphasize that even if physically open, the corridor would have been a challenging, patchy route until certain ecological thresholds were crossed. The coast offers a complementary logic: marine resources, kelp forests, and a string of river mouths where anadromous fish promised seasonal abundance. These are not mutually exclusive models. People are good at using more than one pathway over centuries. The important note is caution with absolutes. Neither route cancels the other, and regional patterns of Clovis and pre-Clovis finds suggest multiple strategies over time rather than one bottlenecked march. The East tells a slightly different story. Here, forest edges, wetlands, and river terraces dominate the record. Mastodon-bearing bogs, kettle lakes, and mucky floodplains captured wood, bone, and sometimes the cut marks and breakage patterns that speak of butchery and marrow extraction. Where Clovis-like points occur, they are joined by other tools designed for working plant and animal materials, suited to wetter, more closed environments. The same fluting technique fits a different mosaic, an adaptability worth noting when we think of how quickly a technological idea can be taught across ecological zones. Listen, for a second, to the soundscape rather than the map. Wind through grass that has not yet met the steel plow. Ice-calving hours to the north, with a sound like distant thunder. Sandhill cranes calling over a wet meadow, a fire cracking low, while sinew dries tight around a haft. A river not yet domesticated, changing course at a whim, building bars and cutting banks, leaving in the cut the layers that, millennia later, will let someone say with care, "This flake lay below that ash lens." Landscapes are not backdrops. They are partners in the making and spreading of ideas. All of this, the shelves, the lakes, the corridors, the grass, the wood, is why a horizon could happen. People who teach one another risky, elegant steps in stonework do not do it in the abstract. They do it on the way to water, on the lee side of a boulder where the wind permits signaling, beside a kill where time matters and repairs must be quick. The world at 13,000 BP offered both the constraints to favor portable, maintainable hunting systems and the meeting points, seasonal congregations at river crossings, quarries, fish runs, where techniques could be watched, copied, and refined. In the next part, we'll leave the map and come in close to the artifact itself, its geometry, its edges, and the small, telling details that turn a stone into a Clovis point. Set one on a clean palm under steady light, and you'll see, first, the promise of symmetry. Not perfect, the human hand doesn't do perfect, but a persuasive balance from tip to base, from left edge to right. The outline is lanceolate, leaf-like, widest a little above the midline, then narrowing to a keen tip. The base is not square, it is gently concave, often with small ears at the corners. Run a fingertip carefully down each edge, and you'll feel alternating facets, the record of thinning flakes removed from both faces. Stop at the very base and the sensation changes. It is dull, almost silky. That's basal grinding. The maker abraded the contact surfaces so lashings would not be cut. Turn the point and find the signature, a flute, or sometimes two, elongated channels struck from the base up the face, typically reaching a third to half the length, occasionally more, sometimes much less. The flute is not decoration. It thins the hafting area so the base can sit deeper and more securely in its socket without adding bulk. It also helps align the point along the foreshaft's axis, reducing twist and improving energy transfer on impact. You can think of it as an interface optimization between stone and wood. Dimensions vary by region, raw material, intended use, and the point's life history. Many complete Clovis points fall in the range of roughly 6 to 13 centimeters long, a couple of centimeters wide, and less than a centimeter thick at the midsection. Some are stout, favoring durability. Others are slim, favoring penetration and flight. Weight matters when you are throwing or thrusting a composite weapon system. Shaft, foreshaft, bindings, adhesive, and stone need to balance. Too heavy a point and the dart arc short or wobbles. Too light and it may shatter on contact or fail to penetrate deeply. The working design sits between these extremes, tuned by craft memory rather than equations, though fracture mechanics would recognize the choices. Look closer and you'll notice two complementary strategies in the thinning scars. One is careful bifacial reduction, with flakes removed alternately from each face to approach a thin, even cross-section. The other, seen on some Clovis assemblages and much discussed, is overshot flaking, also called outre passé, thinning flakes that travel so far across the face that they remove a portion of the opposite edge. To the uninitiated, this looks like an error, a catastrophic overreach. To nappers replicating Clovis methods, controlled overshots can be a fast, efficient way to take mass out of the center while straightening edges. They are risky. Done well, they create the long, clean facets you can see even to the naked eye. Done poorly, the piece snaps and goes into the discard pile. Experimental work suggests makers accepted this risk because speed and quality gains outweighed losses when raw material was abundant and skill was high. Now, the flute. Making one is an exercise in controlled danger. The craftsperson first prepares a small nipple or platform at the base, sometimes by grinding, sometimes by slight beveling, to set up the launch. They support the piece on a firm, yielding surface, an anvil pad of wood or antler, so energy travels where they want it. Then they deliver a strike or heavy pressure to detach a long flake whose bulb initiates at the base and runs up the face. If the piece was too thick, the flute will stall. If the platform is too strong, the flake will shatter short. If the piece is too thin or unsupported, the point snaps. Many fluted points show short, aborted channels alongside longer ones, or a successful flute on one side and only a shallow scar on the other. Real-world results, where good enough often beat ideal. Failure rates and replication are not trivial, even for expert nappers. That tells us something about training investment and the social value of the finished product. What did the flute do in use, beyond seating? Micro-wear studies, examining edge rounding, polish, and microscopic flake scars under reflected light, show that Clovis points functioned as tips for thrusting and throwing. Many bear damage patterns consistent with high-velocity impact, step terminations at tips, lateral snap fractures near the midsection, bending breaks radiating from haft lines. Haft polish and striations often concentrate near the ground base and along the edges near the basal corners, the places that sat under binding and against adhesive. Residue and protein analyses, where preservation and protocols allow, have occasionally detected animal proteins consistent with large mammals. Results are reported cautiously, but the emerging pattern supports the obvious design intent. Follow a point through its working life, and its silhouette changes. After impacts and resharpening, the edges creep inward, the tip is re-established, the shoulders retreat slightly, the overall profile narrows. What began broad and leaf-like can end slender, even needle-like, before final failure. On some sites, archaeologists can lay out multiple resharpening stages, a sequence of lives nested within one tool. This matters when we talk typology. An assemblage with many narrow points might not reflect original design so much as the end of a resharpening trajectory. Understanding that trajectory keeps us from mistaking late-stage survivor for different type. Not every lanceolate point with a basal concavity is Clovis, and not every Clovis point looks textbook. Regional expressions, names like Gainey, Barnes, and others, carry local habits in shoulder height, flute length, and base shape. In the West, raw glassy obsidians encourage slightly different thinning choices than eastern cherts and jaspers. Some regions show frequent bidirectional fluting. Others favor a single long channel. Basal concavity depth varies. Edge grinding can extend further up the blade in some traditions, perhaps reflecting hafting differences. Within this variability, the family resemblance holds. Basal thinning by fluting, ground bases, bifacial thinning to an elegant cross-section, and a design aimed at mounting securely on a replaceable foreshaft. One persistent question is whether fluting improves penetration by channeling fluids or reducing drag. It is an attractive hypothesis because it assigns a dramatic in-flight or in-wound effect to a visually striking feature. Controlled penetration tests with replica points and standardized media have returned mixed results. The strongest, least equivocal benefit remains the mechanical one in hafting. That said, function is often plural. A feature chosen for one reason can deliver minor gains elsewhere, and nappers living with the results would have noticed. Our cautious phrasing then, the primary, well-supported function of fluting is haft optimization. Any secondary effects on penetration are plausible but not necessary to explain the design. Another question concerns why fluting appears when and where it does. If thinning a base is the goal, there are other methods. Basal grinding alone, careful beveling, or simply making a thinner blank from the start. Fluting is risky. Why choose it? The answer likely sits at the intersection of performance, pedagogy, and signaling. Once a community masters the choreography that makes fluting reliable enough, the payoff in standardized, easily hafted tips is significant. The look of a well-fluted point also communicates competence. In tool traditions worldwide, visibly difficult techniques often persist because they encode teaching lineages and trust. When the point maker can do this, you can trust the point. Nothing about this anatomy tells us what language the maker spoke, what stories were told over the fire, or which marriage rules bound neighboring camps. Technology is not identity, but anatomy does reveal priorities: secure hafts, maintainable edges, aerodynamic balance, and enough robustness to survive the first bad hit. You can read a lot from that list about lives lived in motion across big landscapes, under time pressure, and with knowledge networks strong enough to spread hard-won methods quickly. Set the point down now and look at the debris it implies. Core tablets, thinning flakes, tiny resharpening spalls, snapped failures from fluting attempts. A camp's floor could hold this whole micro-history if only the wind and water were kind. Where those floors are intact, the anatomy of one tool blossoms into the anatomy of a kit. Large bifaces for preforms and knives, scrapers for hide, gravers for notching, perhaps osseous points or wedges where bone preserved. Clovis is a point, yes, but also a system, and systems live in sequences of action, not just in single artifacts. In the next part, we'll go from the finished form to the choreography of making, through the napping shed, the platforms and supports, and the moment when the flute either sings or the stone snaps. Step into the napping shed, whether that's a real lean-to behind a lab, a tarped square on windless ground, or a designated tarp under cottonwoods by a creek. The floor is already a small galaxy of glittering flakes, each one orienting pale faces to the light. Tools are simple and purposeful. Hammerstones graded from river-worn cobbles to fist-sized ovals. Billets of antler and dense hardwood, antler tines for pressure, a padded anvil of end-grain wood, leather pads, a knee rest, and the quiet presence of water for wetting hands and tamping dust. This is where a stone becomes a point by subtraction, each removal a sentence that can't be taken back. You start with raw material. The choice is both geology and intention. A fine-grained chert with predictable fracture, a smoky piece of obsidian that loves to travel as a conchoidal wave, a tight-grained chalcedony with a stubborn personality. If the chert is tough and sugary, a heat treatment step may precede everything. Slow ramp up to a few hundred degrees, long soak, slow cool, never an open flame, never a shock, transforming the internal microstructure so flakes release with a silkier feel. Not every tradition uses heat, and not every stone needs it, but when done right, the sound of the blow changes. Less gravel, more bell. The first goal is mass management. You reduce the nodule to a bifacial preform, thin enough to speak of future edges, thick enough to forgive mistakes. With percussion, you strike toward the center line, flipping the piece across your thigh or pad between removals. Each flake initiates at a prepared platform, an angle slightly under 90 degrees, ground enough to keep the blow from crushing, supported in the offhand so the energy does not leak into the air. The scars grow long and meet like shallow river valleys. You chase hinges, erase steps, keep the outline flowing. This is not fussing. It is establishing the future by removing the past in order. When the blank reads as potential, length, width, thickness arranged in a credible triangle, you switch to thinning. Some traditions accept the slow elegance of alternate face percussion with billet and hammerstone. Others invite risk for speed by throwing overshot flakes that cross the midline and exit the opposite edge, straightening and lightening in a single, bold pass. Practice has taught you to seat the piece on a resilient pad, to strike low and forward, to angle the blow so the wave moves under mass and not into air. When an overshot goes right, the scar is long and gleaming, and the edge it leaves is straighter than a rule. When it goes wrong, the piece snaps with a sound that makes everyone in the shed go still for a breath. That quiet is part of the apprenticeship too. Edge regularization comes next, a dance of percussion and pressure that takes the blank from credible to graceful. You begin to feel the point's balance in your wrist, the way it wants to orient along its axis, the way a future tip will pull the line. Basal area is left slightly thicker for now, a reserve of strength to survive the risky act ahead. Grinding happens early and often, where bindings will later sit. You run a coarse stone or a battered flake along the base and a short way up the edges, dulling sharpness so sinew will not be cut. The rest of the edge remains a promise. Now the flute, the moment audiences lean forward for, and makers respect with, a small ritual of preparation. You create a nipple platform at the base. This can be as subtle as a slight bevel with abrasion, or a more explicit rounded protrusion formed by trimming and grinding until it presents a strong, narrow initiation point. Support is everything. One method nests the point on a firm wooden anvil, base outward, with the maker's body weight pinning the midsection through leather and pad, so the shock runs up the face rather than rebounding. Another uses a crutch, or ishi stick, a levered pressure tool, to push off a long flake with controlled rising force. A third blends the two, indirect percussion with an antler punch set precisely on the nipple, then struck by a billet while a helper braces the piece so flex becomes flute, not fracture. Your breath changes here, in through the nose, out slow. The strike is quick but not violent. The pressure push is steady but never static. On a good day, the bulb pops at the base. A smooth wave runs, and a flute slides up the face for a third, a half, sometimes more of the length. On a less good day, the flake stalls after a short run and leaves a shallow, serviceable channel. On a bad one, the point snaps across the hafting area, and you are back 2 hours, or 10. Modern replication under controlled conditions still reports failure rates that make this choice significant. Communities that chose fluting had solved this with training, shared jigs, tacit body knowledge, and the willingness to accept losses for the performance and standardization gains fluting delivered. If the first flute is short, you may attempt a second on the opposite face, partly to thin further, partly to even stress. Some points show alternating attempts, one long, one short, telling of makers who understood enough, as well as ideal. After fluting, you revisit the basal corners. Grinding extends along the lower edges. Tiny nibbling removals regularize the curve, so the base seats well in a socketed foreshaft. The blade edges receive final pressure flaking, small, consistent bites that leave a very fine, regular serration invisible at a distance but palpable to a thumbprint. The tip sharpens last, quietly, as if not to tempt wind. Around the shed, bystanders read the results the way musicians rate each other's phrasing. The long, straight flute says confidence. The absence of step fractures says good support. A faint twist in the blade hints at a moment when mass pulled a flake a little sideways, corrected later with counter removals. None of this is vanity. It is the grammar of performance. A well-thinned base will bind hard but release cleanly if the foreshaft must shear on impact. A straight axis will fly truer from an atlatl dart. A blade with enough meat behind the edge will survive a tough hide before resharpening takes it in. The hafting kit waits nearby. Sinew from leg tendons has been soaked and teased into ribbons. Plant fibers have been twined as backups. Adhesives are warming, a pitch blend of conifer resin with a touch of charcoal, and maybe a breath of beeswax for toughness. The foreshaft socket is cleaned, charred lightly to harden the surface, then scraped to fit. When the point slides home and the bindings pull tight, the flute's gift is obvious. The join is compact and deep. The lashings lie against a dull, ground stone, and the whole assembly feels like a single intention, rather than three parts politely agreeing. A note on teaching. Napping is language without words, learned by watching, by feeling someone else's hands set yours, by hearing the difference between a blow that moves a wave and one that crushes a platform. A horizon as broad as Clovis implies not only travel and exchange, but pedagogy, occasions where groups meet and someone says, without saying, hold it like this, lean like this, strike here. Experimenters report that even after years of practice, the small improvements never stop. You begin to trust edges you once feared, to read flaws in raw stone before they bloom, to know when to accept a short flute because the blank's internal voice says no further. That voice is how traditions persist. It's also how they change. And a note on humility. In replication sheds today, with modern safety glasses and infinite practice stone, points still snap and flutes still stall. The ancient makers managed this in weather and time pressure, on travel schedules written by animals and seasons. The polish we see near the base, the repeated resharpening scars, the final failures, these are the normal outcomes of tools doing work, not the misfortunes of flawed design. The beauty we admire was never separate from use. Gather the debris, bag the point, sweep the flakes into a tray for analysis. Platform angles, termination types, cortex percentages. Each tray is a tiny history of choices that will matter when the artifact leaves the shed and enters the ground. And when, long after, someone reads a floor as a day's work, rather than a scatter of chance. In the next part, we'll step away from the shed and ask how archaeologists preserve that day's work in context, through stratigraphy, provenience, and the careful recording practices that turn a point from a pretty isolate into a trustworthy data point. Before a point can answer big questions, it must answer small ones. Where exactly did it lie? What exactly lay above and below it? Which grains of sand kept it company? Which flecks of charcoal? Which bones? And which roots? Archaeology earns its authority not from shining artifacts, but from the relationships between humble things, measured and recorded with patience. In this part, we'll slow down to the pace of layers, lines, and notes, how context is built so later claims can stand. Start with stratigraphy, the simple, powerful idea that, barring disturbance, lower layers are older than higher ones. The Earth writes this logic in colors and textures, a tan sheet of windblown silt, a darker band rich in organics from a long, quiet period, a sudden ribbon of sand from a flood, a thin, gray lens of ash from a fire that wandered across a meadow and into the record. In a good profile, you can read seasons turning into centuries. The job is to expose that profile cleanly, describe it carefully, and test it enough to be sure you're seeing processes rather than guesses. Micromorphology helps here. A small, undisturbed block of sediment is cut out, hardened in resin, and sliced thin enough to read with a microscope like a slide of the Earth's memory. Under crossed polars, grains reveal whether they settled from air, water, or footfall. Ashes show whether they are hearth residue or wind-blown. Tiny channels betray the work of roots and burrowing insects. If a Clovis Age flake rests on a compacted living surface with microstratified ash above, that is different. In weight, from a flake perched in loose colluvium, washed down a slope decades or millennia later, thin sections turn hunches into diagnoses. Provenience is the companion term to stratigraphy. It is the exact three-dimensional location of a find, X, Y, Z, tied to a site grid and a vertical datum, so anyone can return to that point in space in their mind. Good fieldwork treats provenience as non-negotiable. Flags mark finds as they are exposed. Total stations or laser scanners capture coordinates. Photographs with scales fix orientation. Forms record associations. Flake cluster 23 within feature 5, east wall 103. 42 meters above datum, immediately below ash lens A. The language is dry on purpose. It is the scaffolding that keeps interpretation from drifting. Features, the non-portable elements of a site, matter as much as artifacts. A hearth basin, a post-hole stain, a pit backfilled with flaking debris, a buried surface worn smooth by traffic. Each binds artifacts to activities. A fluted preform found within a discrete napping floor, surrounded by thinning flakes that refit to it, anchored by a hearth whose charcoal returns a tight cluster of dates. This is a different kind of evidence from a single point plowed up by a tractor in the 20th century and handed over with a good heart and a fuzzy memory. Both are interesting. Only one can bear much interpretive load. Refitting is a quiet triumph of context. When analysts take flakes from a napping floor and, like a patient puzzle, fit them back to a core or preform, they demonstrate that the scatter is intact, that gravity, water, and time have not scrambled the story. Refits can extend across meters, tying separate clusters into a single episode of work. When a flute channel flake snaps perfectly into the base of a point, found a meter away, you can feel the day reassemble. Someone struck here, a flake flew there, and the debris came to rest without later blending. Refits win arguments that words alone cannot. Not all disturbance is obvious. Bioturbation, roots, rodents, insects, move small things vertically and sideways. A mole's tunnel can lift a flake, a burrowing beetle can carry microscopic charcoal, a root can pry apart a contact and let silt sift down. This is why archaeologists sample broadly and redundantly. Trench walls are cleaned and read like sentences. Multiple columns are taken for sediment, pollen, phytolith, or charcoal. Magnetometry or ground-penetrating radar may map buried features before a trowel touches soil. The goal is to understand not only what is present, but what processes have visited since deposition. Water complicates and clarifies. In caves and rock shelters, dripping ceilings, roof fall, and slope wash can create layered cakes where cultural materials sit among natural arrivals. In floodplains, overbank deposits blanket camp floors with fine silt in a single event, sealing them like pages between tissue. In submerged contexts, springs and sinkholes, the water can preserve organics beautifully while also making excavations slow and exacting. Each environment asks for tailored methods, pump screens and provenience lines underwater, micro buckets and sieving through fine mesh for tiny bones on land. Constant checks that the layer you think you are in is the one your notes say you are in. Sieving is where many of the small truths live. A 1/8-inch mesh is standard, 1/16-inch or finer reveals fish bones, tiny debitage, seeds, and insect parts that change interpretations. A hunters-only camp can become a mixed-use household once needles, beads, and plant remains appear in the pan. For Clovis Age contexts, small retouch spalls and basal grinding dust are especially telling. Their presence near a point says repair happened here. Their absence may say the point arrived finished, was lost, or was abandoned after a break. Caches add another kind of context. Across North America, archaeologists and careful finders have documented buried collections of large bifaces, preforms, and occasional finished points, deliberately placed and sealed. Some are Clovis Age. The assemblage composition, raw materials, often exotic, and arrangement speak to logistics and planning, a mobile group creating a savings account of stone along a seasonal route. or perhaps a ritual emplacement we do not yet fully read. Because caches are often found by chance, documenting their stratigraphic position and sealing matrix becomes urgent. Even in those imperfect circumstances, careful mapping and geochemical sourcing can recoup a great deal. Ethical note: many sites that speak to Clovis and earlier occupations sit on lands with deep meaning to indigenous communities. Excavation is not neutral. It disturbs places and sometimes involves destructive sampling of rare materials. Best practice today requires consultation and partnership, invitations to advise, agreements about sampling limits, shared stewardship of finds and data, and, where appropriate, decisions not to excavate at all. Respect is not a footnote, it is a method. It improves science by expanding who frames the questions and who holds the results. Documentation has moved from paper to pixels without losing its core discipline. High-resolution photogrammetry can turn an exposed floor into a 3D model where every flake is measurable later at a desk. LiDAR scans anchor features to millimeter precision. Tablets replace clipboards but still ask the same fields: layer, feature, association, notes. Redundancy remains the watchword. A model, a plan map, and a field sketch together are better than any one alone. The dream is that future researchers, with better tools, can re-walk the site in data and test our interpretations against the same ground. All of this care pays dividends when we bring in dates. A charcoal fleck's number by itself is a whisper. A charcoal fleck drawn from a hearth basin, under a cap of silt, with a fluted point resting in the floor next to refitted flakes, becomes a voice. Because radiocarbon returns ranges, not certainties, we want many samples from well-understood positions. We want to avoid contamination, rootlet intrusions, old wood effects where long-lived trees skew ages, and humic acids that smear signals. Pre-treatment in the lab removes many of these problems. Field judgment prevents more by choosing short-lived materials, seeds, twigs, when possible, and by bracketing deposits with multiple samples above and below. Provenience also governs negative evidence. When a layer yields expedient flakes and faunal remains but no points, and the layer above yields a Clovis assemblage, that vertical separation matters. It allows us to say, earlier people without fluting were here, cautiously, without dragging materials across time. Where slope wash or burrowing has collapsed layers, that claim must be tempered or withdrawn. The discipline is not in making bold statements. It is in knowing when the ground won't support them. Sometimes the best decision is to stop. If a profile shows too much mixing, if a landowner's conditions change, if consultation reveals concerns, if rising water threatens safety, the right move is to cover, record, and wait for a better season or a different question. Patience is part of method too. In the end, stratigraphy, provenience, features, refits, micromorphology, and documentation form a single instrument: context. It lets one artifact stand for more than itself without overreaching. It lets us decide whether a Clovis point is a traveler's loss, a kill's residue, a household's repair, or a cached intention. And it sets the stage for the next tool in our kit: time. In the next part, we'll turn that instrument toward dating, how radiocarbon works, what calibration does, and how Bayesian models weave many measurements and layers into the most probable sequences that frame the Clovis horizon. Time, in archaeology, is a braid of measurements and judgment. Radiocarbon is our most familiar strand, but by itself it is a number that whispers. Context lets it speak. Modeling lets many whispers find a chorus. Tonight we'll keep the pace gentle and the details honest, stepping from carbon atoms in a lab to calendar ranges on a page, and then into the Bayesian scaffolding that turns scattered samples into likely histories for the Clovis horizon. Begin with the principle. Living things exchange carbon with the atmosphere or water. While alive, their tissues carry a proportion of radioactive carbon-14 that matches their environment. When they die, exchange stops and 14C decays at a known rate. In the lab, technicians measure the remaining of 14C relative to stable carbon and report an age in radiocarbon years before present, with present defined as 1950. Those raw numbers are not calendar years. The atmosphere's 14C content has wobbled through time. Calibration curves, built from tree rings, corals, and other archives, map radiocarbon years to calendar years, yielding the ranges you hear in careful speech, about 13,000 calibrated years before present. The samples themselves matter profoundly. For the late Pleistocene, we often date short-lived materials, twigs from hearths, seeds, small bone fragments with good collagen. Short-lived is key. It prevents the old wood problem, where a long-lived tree's heartwood reads centuries older than the fire that burned it. Bones are persuasive when collagen is preserved and pre-treatment removes contaminants. Shells can be useful, but must account for marine reservoir effects. Freshwater shells and fish can carry gypsum, old carbon from dissolved limestone, yielding ages that skew older than reality. In waterlogged or submerged sites, dissolved humic acids can infiltrate pores, adding younger carbon. Aggressive pre-treatment counters that. Good labs document pre-treatments with the same discipline field workers document layers, what was removed, how, and why. Accelerator mass spectrometry, AMS, has changed the field by requiring much smaller samples and offering high precision. Yet precision is only virtue when accuracy is earned. A single lovely AMS date, lifted from a fleck of charcoal with an uncertain relationship to a point below it, is not a sturdy beam in a house of claims. Better is a bracket of dates above and below a floor, a cluster from a single hearth, a pattern that repeats in adjacent squares, all with pre-treatment appropriate to their material. Calibration adds another layer of humility. The curve is not a straight line. It has wiggles and plateaus where the same radiocarbon age corresponds to broad calendar intervals. At exactly the time we care about, near the Pleistocene-Holocene transition, parts of the curve widen. A single measurement may translate to a calendar range that feels frustratingly large. The answer is not to bully the number into certainty. It is to bring more and better numbers from clearer positions and let them work together. This is where Bayesian modeling enters, not as magic, but as disciplined bookkeeping that honors both data and stratigraphy. In plain language, a Bayesian model lets you tell the computer what you already know. Layer B lies above layer C. Feature 5 is a hearth within layer C. A Clovis point sat on the surface of layer C. And then ask, given those relations and these radiocarbon likelihoods, what is the most probable sequence of events and their start and end boundaries? Software packages commonly used for this, think of them as careful abacuses for time, accept dates with their laboratory uncertainties and integrate them with stratigraphic priors, returning modeled age ranges with credible intervals. A useful feature of these models is outlier detection. Not every date you feed the model deserves equal trust. Some samples were infiltrated, some contexts were less secure than hoped, some pre-treatments failed. Rather than discarding inconvenient numbers by hand, you can assign each date a modest probability of being an outlier. The model then downweights dates that do not fit the larger sequence. It is not a license to force data to obey stories. It is a way to let the whole dataset express its own coherence and to flag which samples need rethinking or redating. Think of a Clovis-bearing site with a napping floor and a hearth. You have 5 AMS dates from tiny twigs within the hearth fill, 2 from just beneath the floor, and 2 from immediately above in a ceiling silt. Individually, each date offers a calibrated range. Together, with stratigraphic order enforced, the model can estimate the start and end of the occupation phase, with narrower credible intervals than any single date. The hearth cluster constrains the middle, the bracket dates set limits. Any older intruding charcoal in the floor gets gently discounted by the outlier model if it insists on an implausible age. The result is a transparent, testable estimate for when people left the debris we now read. Models can do more. If a site has stacked occupations, pre-Clovis below, Clovis within, later Paleoindian above, you can model phases separately and the gaps between them as well. If a region contains many sites with similar material culture, you can model each and then ask about overlap. Did Clovis in the plains begin earlier than in the southeast? Did it end around the time certain regional styles emerged? These are not yes-no questions. They are probabilities with honest uncertainty. A good model will show it's working. Posterior distributions, agreement indices that warn when the data are at war with the specified order, and sensitivity tests that ask how much any single date is steering the outcome. A caution about summed probability distributions, SPDs, across many dates. They are tempting pictures, curves that rise and fall, suggesting population pulses or cultural booms. But SPDs are shaped by sampling intensity, preservation, research history, and the quirks of the calibration curve. Peaks can appear simply because more dates were run in a period of fashionable interest. Troughs can reflect a plateau in the curve rather than a real lull in human activity. Used carefully, SPDs can inform; used naively, they narrate noise. The cure is context, regional subsetting, and honesty about biases. What do careful models tend to say about the Clovis horizon? Spoken cautiously. Across many regions, Clovis-like occupations cluster within a few centuries near the end of the Pleistocene, with beginnings and endings that vary by place. In some interior locales, modeled starts may sit slightly earlier than in far eastern settings. In others, appearances are nearly coeval within error. Ends cascade into successors, Folsom in parts of the West, unfluted lanceolate and other regional forms elsewhere, rather than halting on a single date. The Younger Dryas onset is nearby in time, but nearby does not prove causation. Some models suggest overlap, others a staggered handoff. The strength of the Bayesian approach is that it keeps those subtleties visible and avoids the false crispness of one-number histories. Ethical note on destructive dating. Each sample represents the partial consumption of a rare record. Today, many projects negotiate sampling strategies with indigenous partners and commit to minimal, targeted extraction, open data sharing, and archiving raw and processed results, so future teams need not spend tissue to repeat work. Time knowledge should not exhaust the very past it measures. Finally, what will tighten Clovis chronologies further? More short-lived samples from secure, modeled contexts, independent methods where possible, tephra correlations, varv counts in nearby lakes, dendrochronology for younger horizons, and replication across labs. Equally important is publication transparency, raw measurements, pre-treatment details, find photos in situ, and open access to model code so others can rerun and challenge conclusions. Time in archaeology advances by reproducibility as much as by new dates. Step back. Radiocarbon gives us numbers. Calibration places them on the calendar. Bayesian modeling weaves many such numbers with the truths of layers into plausible, explicit sequences. When we say, Clovis in this valley likely peaked between these centuries, we mean it in that layered, humble way, ready to be improved rather than defended. In the next part, we'll leave the lab bench and return to the ground, walking kill sites, camps, and the carry kits that connect them, to see how Clovis technology lived its days. Walk with me to 3 kinds of places where Clovis technology leaves its clearest signatures: the kill, the camp, and the cache. Each speaks a different dialect of the same language: work under time pressure, decisions about movement, and a preference for tools that can be repaired far from home. Begin at a kill on an open terrace, the river only a bend away. The ground is a mosaic of trampled silt and churned sand, footprints long gone but the motions still legible. Large bones lie where gravity and butchery put them, ribs in arcs, vertebrae like a row of knuckles, limb elements splayed to expose marrow. The marks are quiet and exact, long, shallow cut marks where hide was opened and peeled, deep striations at tendon attachments, percussion scars at marrow-rich shafts. Nearby, a fluted point lies snapped at midsection. The basal half still bears the polish of hafting, the blade half stepped where impact forced a brittle decision. A few blades and flakes lie where hands pause to resharpen or to improvise a new cutting edge. If you sift the sediments fine enough, you find tiny spalls that fell from the edge while dressing a hide slick with fat. Sites like this are known in several regions. On southwestern terraces and plains floodplains, Clovis Age mammoth localities have yielded combinations of butchered bone and fluted points or preforms in primary contexts. No two are identical. Some preserve a single animal processed thoroughly. Others tell of multiple individuals and repeated visits stitched together by layers of silt. The common thread is choreography: intercept, wound, finish, process, and move before weather and scavengers rewrite the floor. Impact damage on points, resharpening debris, and the distribution of tools across the bone bed make the sequence readable even when words fail. How did the weapon system work in these moments? The balance of evidence favors spear throwers, atlatls, propelling light darts tipped with fluted points, mounted on foreshafts that could shear off on impact. Thrusting was surely used at close quarters, but damage patterns and the need for standoff suggest thrown weapons did much of the first work. The flute earns its keep here. A thinned ground base seats deep, lashings sit against dulled stone, and the foreshaft can be replaced quickly while the main shaft stays straight and dry. In a landscape where a second opportunity might mean the difference between a full camp and a hungry one, that replaceability is design compassion. Step back from the drama of a kill to a camp's slower grammar. On a stable surface, river levee, dune lee, rock shelter bench, the record tightens into clusters. Here, a hearth basin with reddened sediment and charcoal. There, a napping floor with thinning flakes fanned like petals from a day's work. A ring of small cobbles anchors a pot that never existed, but whose space is marked by the absence of debris. If preservation is kind and excavation slow, refits bind the scatter into episodes. A biface blank carried in, thinned with a run of overshot flakes, the edges regularized by pressure, the basal corners ground, an attempt at fluting made and accepted at short but serviceable. A few meters away, a cluster of small flakes and a scraper spine, grease-darkened, speak of hide work. Plant remains, seeds, nutshell fragments, bits of phytolith-bearing tissues, turn a hunter's camp into a household. The toolkit in camp reads like an inventory you can carry in two hands, large bifaces that travel as both knives and cores, ready to be converted forward into points or blades. Finished points at multiple life stages, some broad and fresh, others slimmed by resharpening to a last useful profile. End scrapers and side scrapers with working edges rounded by hide, gravers for notching or engraving, borins or burn-like spalls for splitting, flakes opportunistically used and then discarded. If bone and antler preserve, you may find wedges, awls, and straight rods, pieces some interpret as foreshafts or as billet punch tools in manufacture. The ratios shift by region and raw material availability, but the logic is steady. A small, flexible kit that can be fed by local stone or by reshaping what you already carry. Water and seasonality sculpt these camps. Along spring-fed channels in the southeast and Florida peninsula, lower sea levels and karst made sinkholes and springs magnets for both animals and people. There, underwater excavations have recovered late Pleistocene floors sealed beneath slow sediments, their quiet enriched by preservation of wood and plant fibers. On the plains, overbank silts did the sealing work. In the basin and range, rock shelters patched by slope wash and drip-sealed stacked occupation. Each environment writes a different epilogue. A wind-blown dune will scatter a camp's light debris and leave only heavy pieces. A rock shelter will trap ash and fine debitage under a rockfall that later serves as a page marker. Carry kits, link kills, and camps. Imagine lifting your toolkit at dawn, 2 or 3 large bifaces at different stages, each an insurance policy, a handful of preforms that can become points, 1 or 2 finished points mounted, and a few spare foreshafts wrapped tight with sinew against warping, a bag of platform abert or stones, a billet, a tine, a small packet of pitch. If good stone is distant, those bifaces are not just tools, but traveling quarries, mobile cores that can be reduced toward utility as needed. The presence of far-traveled raw materials at many sites, obsidian with trace element fingerprints, distinctive cherts and jaspers, whose outcrops lie 100 or more kilometers away, speaks to movement and to exchange. Sometimes the movement is literal, a person walked with stone. Sometimes it is social, a meeting at a quarry or a fish run where materials change hands along with stories and spouses. Caches add a cool, deliberate note to this picture. Several Clovis Age caches, assemblages buried together, often of large, carefully made bifaces and occasionally finished points, have been documented across the West and Plains. Many feature exotic raw materials and pieces at early reduction stages, stored not as trash, but as intention. One reading is purely logistical. Plant a stash along a known seasonal round so that when you return, the stone is already there and transport costs are lower. Another reading admits signaling, a cache as a display of craft and a claim to place, perhaps revisited by the same lineage across years. With caches found by chance, provenience can be imperfect. Yet even then, the combination of artifact form, raw material, and weathering tells us we are looking at packages, not accidents. They remind us that mobility is planned as well as improvised. Not every kill with big bones and sharp stones is a kill. Taphonomy, the science of what happens after death, keeps us honest. Carnivores break bones too. Trampling leaves its own polish and striations. Water rolls artifacts and reorganizes bone beds. The persuasive Clovis Age kill locales are those where multiple lines agree. Primary context, cultural breakage patterns, cut marks with the right microscopic profiles, embedded or closely associated points or preforms, and a stratigraphy that brackets the event in time. Even then, we say butchery with probable hunting, not a cinematic chase, because caution is part of what makes the story trustworthy. A respectful note about burials. One of the most discussed Clovis-associated finds is a child's burial accompanied by artifacts and ochre, a rare and powerful context that has contributed to discussions of ancestry through ancient DNA. These are not just data points, they are persons and practices. Today, many projects work in open partnership with descendant communities, and decisions about sampling, publication, and curation are made together. The science is better for it. The story is kinder. When you zoom out from these three places, the kill, the camp, the cache, you can feel the rhythm of a technological horizon lived day to day. Points are not icons, they are participants in problems. How to close distance on skittish game, how to keep a kit light but capable, how to teach risky steps so failure stays affordable, how to bridge raw material deserts, how to leave the least behind when you move. The details change across prairies, pines, savannas, and sagebrush basins, but the through line remains a preference for composite, maintainable weaponry, and a craft pedagogy strong enough to standardize hard techniques across distance. Set your palm flat and imagine the weight of the kit again. It is not heavy, but it is dense with decisions. Each biface a promise, each flute a risk accepted for the sake of reliability at the join. Between kills, camps, and caches runs a path that is both geographic and social. Trails to quarries, crossings at rivers, rendezvous where techniques are shown and corrected, stories traded, alliances renewed. In the next part, we'll track the stones themselves, how raw materials move, what sourcing reveals about mobility and exchange, and how a point's geology can redraw the map of its maker's year. Hold a point up to the light, and it will tell you two stories at once: the universal language of shape and the local dialect of stone. Geometry travels easily, geology does not. In the late Pleistocene, raw materials anchored lives to places even as people ranged widely. Follow the rocks and you sketch itineraries, seasonal rounds, rendezvous, and the long arcs along which ideas and obligations moved. Begin with 3 stones on a table. The first is a translucent smoky glass, obsidian, so fine-grained it breaks like frozen water. The second is a honey-colored chert with tiny, even crystals, the sort of stone that takes a flawless edge and keeps it. The third is a tough, speckled quartzite whose grains are larger and whose fracture is less predictable but still workable in experienced hands. Each demands a slightly different choreography. Obsidian loves pressure flaking and yields long, glossy scars. Chert rewards controlled percussion and neat platforms. Quartzite asks for patience and heavier billets. A craftsperson who knows all three can tune a kit to whatever the land offers, or carry preferred stone from far away and make a year bend to it. Where do these materials come from? From quarries and float cobble bars, eroded beds and uplifted seams, ancient river terraces stranded above modern channels, and volcanic flows whose glass snapped into nodules the size of fists. Some sources are unmistakable to the eye once you have learned them: the waxy luster and sugary feel of certain jaspers, the smoky clarity of particular obsidians, the mottled patina of cherts weathered on open flats. Others require chemistry. Trace element fingerprints, measured by portable X-ray fluorescence, PXRF, or lab-based methods, can assign a flake to a volcanic glass dome dozens or hundreds of kilometers away with surprising confidence. Even among cherts and chalcedonies, subtle elemental patterns and petrographic textures can point to districts and, sometimes, to beds. Imagine a Clovis age camp on a river's inside bend. In the debitage, the flakes and spalls, you sort raw materials by eye first, then by hand lens. Here are local river cobbles thinned into serviceable tools. There are exotic pieces with a polish and fracture that speak of distant uplands. The ratio matters. A high proportion of local stone alongside a few curated, high-quality exotic bifaces suggests a strategy. Carry excellence as a reserve and feed the daily edge with what the river gives. In contrast, a site where most of the work rested on exotic materials implies a different rhythm. Perhaps the camp sits near the end of a planned journey to a quarry, or at a rendezvous where groups exchange both stone and news. Archaeologists sometimes talk about provisioning strategies to capture these patterns. One is individual provisioning. People carry finished tools and preforms on their bodies, reducing as needed and replacing from a personal stock. Another is place provisioning. Groups seed key locations on their annual round with caches or raw blocks, so that when they arrive for fish runs, bison crossings, or plant harvests, stone is there waiting. Clovis-era caches of large bifaces fit the second strategy. Curated mobile bifaces reduce step by step toward points fit the first. Most groups likely blended both, carry enough to bridge uncertainty, stash enough to lighten the load later. Distance is written in edge angles and resharpening lives. A highly curated point with narrow, repeated resharpening scars, made from a distinctive non-local chert, might have started as a large, robust preform near its source and crossed many days of travel, giving up width a few millimeters at a time until it failed. A broader, fresh point of local quartzite, used and discarded near a quarry, tells of shorter pathways between source and use. When you assemble a region-wide picture, many sites, many points, many raw materials, the map emerges. Obsidians of the interior west traveling across basins. Plains cherts moving along river systems. Coastal gravels feeding camps with expedient tools as curated pieces save their edges for when it matters. Exchange networks blur the distinction between feet traveled and stone carried. At a seasonal meeting place, a narrows where herds funnel, a canyon mouth with springs, a salmon river in the west coast ranges, groups might gather to court, trade, teach, and resupply. A craftsperson from far north arrives with a bundle of glassy blanks. Another from the east brings honey chert slabs. A third offers finished scrapers and awls in good bone. Stone moves down the line, too, changing hands one camp at a time so that a small piece of distant bedrock ends its life far from its source without any single carrier walking the full distance. The archaeological signature of this is dilution. Traceable exotics present in small numbers across a broad area, with more and larger pieces nearer the source. Mobility is not mere wandering. It is a plan drawn by water, game, and obligations. Picture a year's arc for one small community. Late winter in sheltered river timber, where windbreaks and steady water ease repairs. Early spring move to a quarry on rim country to refresh the kit. Large bifaces struck from high-quality outcrop. A day of overshot thinning that seeds the coming months with potential. Late spring to early summer along a riparian corridor where plant foods and small game stabilize camp life, and children learn the safe end of a billet from the business end. High summer crossing open basins, darts in hand, for pronghorn and bison. Early autumn to a known pass where herds compress and the weather is kind to meat drying. Late autumn toward a spring where a cache was planted last year and is now lifted, inspected, and partly used. Each stop leaves a different ratio of raw materials and tool states. Each becomes, to archaeologists, a clue to the choreography. Sourcing adds resolution to these sketches. In regions with many chemically distinct obsidian domes, a PXRF survey of points in debitage can reveal directionalities. This camp's glass came mostly from the northwest. That cache blended two sources from opposite sides of a range, hinting at a rendezvous. In chert-rich provinces, petrography under a microscope ties a blade's microfossils to a formation, while outcrop visits confirm visual matches and collect comparative samples. When multiple labs and teams converge on the same assignments, confidence rises and the travel lines on the map thicken from dotted to solid. Sometimes the stone itself remembers stress and story. Thermal crazing patterns on a biface suggest it was left near a fire at some point in its life. Heavy macroscopic weathering on one face, but not the other, hints that a preform rode in a kit with one side exposed to grit and sweat. Rejuvenation flakes stacked near the base of a blade say the owner valued that tool enough to keep nursing it forward rather than start anew. In aggregate, these small notes tell of people who moved with intention, repairing rather than discarding, because good stone carried cost and meaning. Ethical note: quarries are not just rock. They can be places of long-standing significance, sources named in stories, marked by petroglyphs used across millennia by many descendant communities. Modern sampling, hammering fresh faces, removing blocks, should proceed in consultation, sparingly, and with full documentation shared. The goal is to learn routes without stripping waypoints. A word about absence. In coastal settings now drowned, the lithic record we can reach is biased landward. Rivermouth camps, rock shelters back from ancient shorelines, and upland way stations. If early groups traveled coasts with watercraft and relied more on perishable tools, their stone footprint would look lighter and more local, with exotic pieces rarer not because people moved less, but because the places where exchange burned bright are underwater. Offshore surveys and submerged site archaeology are beginning to extend the map seaward, but for now, we hold conclusions loosely where the shelf has swallowed the trail. Mobility paths also intersect with teaching paths. Quarries make classrooms. A teenager's first successful platform prep, an elder's subtle correction of billet angle, a demonstration of fluting on a preform that already holds hours of work. These moments happen where raw stone is abundant and breakage costs less. When we see a cluster of novice mistakes amid expert debris at a source, we are likely seeing a school day. The horizon spreads not only because people walk, but because skill travels in public, at places designed by geology to host knowledge. By the end of a careful survey, a region's stone story reads like a braided river, channels that split and rejoin, some carrying heavy loads far, others dropping their cargo quickly and meandering. Clovis-era communities rode those braids, moving materials, methods, and obligations along courses set by bedrock and climate. The points we admire are local in substance and continental in style, because people were both at once, anchored by sources, connected by routes. In the next part, we'll come in even closer to the edges themselves, reading microscopic polish, striations, and residues to ask what Clovis points actually met in use. From hide and bone to the faintest traces of protein and plant, our methods and evidence too. Bring the point under a good light and a better lens. What looks to the naked eye like a clean edge becomes, at 5200x magnification, a landscape of plateaus, microchips, and glossy runways no wider than a hair. Microwear analysis, the reading of microscopic damage and polish, works because different tasks and materials abrade stone in distinctive ways. Hide, soaked and stretched, leaves a smooth, greasy-looking polish that climbs the edge. Dry hide is harsher, with fine pitting. Meat and soft tissue round edges modestly, and produce faint striations aligned with the motion. Bone and dense horn create bright, flat facets with stepped microchipping. Plant contact, reed, wood, can leave fibrous striations and duller, matte swirlishes. All of it depends on time. 5 minutes of use tells a different story than 2 hours. Resharpening resets the script and starts a new chapter. Replication sits at the heart of trustworthy microwear. Analysts build libraries of reference edges by using replica tools on known materials: fresh hide, seasoned wood, bone, meat, under controlled motions: push, slice, drill, scrape. They then compare archaeological edges to those libraries, ideally blind to the site's interpretation. Inter-observer tests, 2 analysts reading the same edge independently, help police our human tendency to see what we hope for. The best studies also report the state of the surface: heavy weathering, sand abrasion in Aeolian settings, or river rolling can mimic or mask use. Obsidian complicates and clarifies. Its glass records fine striations beautifully, but hydrates and devitrifies over time. Chert keeps polish well, but may carry post-depositional film if soils were rich in silica or carbonates. Good protocols clean cautiously, ultrasonic baths in deionized water, no harsh solvents that could remove residue, and document before and after images so cleaning does not erase the very evidence it seeks to reveal. On Clovis age points, recurring microwear patterns are consistent with thrusting and throwing into large animals. Tip damage includes step-terminating microflakes and hinge scars suggestive of high-velocity impact. Lateral snap fractures cluster near inferred haft lines. Bright, flat polish along the basal edges and on the flute margins indicates binding contact rather than cutting. Some blades carry hide-scraping polish away from the tip, evidence that a point, once broken, lived again as a knife or end scraper. The working life was iterative: impact, repair, resharpen, repurpose, retire. Residue analysis extends this picture from motion to material. There are several kingdoms of residue and several generations of method. The earliest widely used protein tests in the 1980s-90s employed immunological assays like crossover electrophoresis to detect blood proteins on stone. Those tests were bold and, in hindsight, fragile. cross-reactivity between taxa, contamination risks in the field and lab, and ambiguous bands produced false positives and inflated confidence. Today, most researchers treat those results as provisional at best. Modern proteomics, mass spectrometry, LC-MS-MS, that reads peptides and matches them to taxon-specific markers, offers a higher bar. When sampling is careful, masking, blank controls, extraction from microscopes within flake scars, and identifications hinge on multiple unique peptides, we can sometimes say bovid, cervid, or, rarely, proboscidean with measured confidence. Even then, diagenesis, protein breakdown over millennia, limits survival. Negative results are not evidence of absence, only of taphonomic truth. Plant residues tell quieter stories. Starch grains trapped in micro-crevices of edges and on tool faces can reveal plant processing. Their shapes and hilum positions identify families, grasses, sedges, and sometimes genera. Phytoliths, silica bodies within plants, survive where starch does not, but many grasses share similar forms and assignments remain broad. For Clovis age points used primarily as weapon tips, plant residues are likelier on scrapers and knives within the same assemblages. Finding them on a point's mid-blade might speak to butchery in a plant-rich environment or to later reuse of a broken tip as a cutting tool. Adhesives and hafting compounds add a third class of residue. Fourier transform infrared spectroscopy, FTIR, and gas chromatography mass spectrometry, GCMS, can identify conifer resins, pinene A derivatives, plant gums, polysaccharide signatures, waxes, and admixtures like charcoal or mineral fillers. Experimental blends, pine pitch tempered with powdered charcoal and a touch of beeswax, leave identifiable chemical fingerprints. Archaeological residues that match those patterns strengthen the inference that the flute's primary purpose was mechanical, thinning the base to fit a glue and sinew join that needed both depth and contact area. Not all hafts preserve residue. Where they do, the chemistry is a small kindness from deep time. Ancient DNA on stone is the most alluring and the most constrained. Direct recovery of faunal DNA from lithic surfaces at late Pleistocene ages is uncommon and must clear high bars. Dedicated clean labs, multiple independent extractions, negative controls at every step, and sequences that match expected taxa while excluding modern contamination. Sedimentary ancient DNA, cDNA, from the sediments around artifacts is more promising in some contexts. Cave floors, waterlogged deposits. But even then, movement of molecules through pores, root channels, and water films complicates association. For our calm ledger tonight, the consensus is simple. A few cases show credible biomolecular identifications on or immediately associated with Paleoindian tools. Many more do not, and that absence is unsurprising given chemistry and time. We lean on microwear and context, and we treat biomolecules as occasional, high-value confirmations rather than routine proofs. Controls are the quiet heroes in residue and biomolecular work. Field teams collect soil from immediately around the artifact and from sterile layers to serve as environmental blanks. Lab teams run extraction blanks alongside samples and sequence whatever appears, so they can subtract common lab contaminants, human keratins, bovine serum albumin, from the final call. When one edge of a point yields peptides, and the opposite, sampled the same worm, yields none, confidence rises that the signal is real and localized. When multiple tools from the same feature produce consistent taxa, say, large cervid signatures across a butchery floor, the pattern speaks louder than any one tool. Even with good methods, we keep the language modest. A peptide match to cervid says, "Deer elk family contact," not, "This point killed a particular animal on a particular day." Starch of Panacoide says grass family processing, not, "This species, this recipe." FTIR bands that match conifer resins say, "Adhesive here," not, "Pine from that ridge." The humility protects the story from drifting past the evidence, and it leaves room for later work with better tools to sharpen the picture. Two additional notes improve our reading. First, time since last resharpening matters. A freshly retouched edge may carry little use wear and few residues even if the tool's previous life was busy. Analysts who map retouch stages along an edge can pair wear to episodes. Second, hafting wear is data, not noise. Polishes and striations within the haft zone tell us about bindings, adhesives, and the micro-motion of a point in its socket. In some cases, they distinguish between dart and thrusting arrangements by the directionality and intensity of friction. All these methods live best when braided with the earlier disciplines: stratigraphy, refits, dating. A fluted point refitted to its flute flake within a sealed floor, with haft polish at the base, tip impact damage, and a proteomic hint of large mammal proteins from a microscrape inside a step fracture. That is an artifact whose voice carries. Add a bracket of AMS dates from short-lived twigs in the same hearth and a modeled occupation window, and you are close to hearing a short chapter from a long book. Ethical note: residues and proteomics require microsampling, abrasion of a few square millimeters, solvent rinses, the consumption of precious flecks. Today, best practice includes explicit consent from collections stewards and descendant communities, full documentation of sampled spots with photomicrographs, and open archiving of raw spectra and sequences so others can reanalyze without resampling. The goal is cumulative knowledge with minimal new cost to irreplaceable objects. Where do these readings leave Clovis function? With a coherent story that is firm in outline and soft at the edges. Composite weapons tipped with fluted points used primarily in hunting large mammals. Frequent repair and reuse. Occasional repurposing of fragments into knives and scrapers. Haft adhesives of resin and gum, strengthened with mineral temper. Bindings of sinew or plant fiber seated against ground bases. And, here and there, molecular traces that tie tools to animals and tasks. Disagreements remain: how often thrust versus throw, how much plant work with points versus other tools. But the center holds when methods converge. Let your eyes rise from the lens for a moment. The point on the tray is less mysterious now, but not less beautiful. Its polish is not ornament, it is biography. Its residues, where they survive, are not miracles. They are accidents preserved by patience and luck. The methods that find them are careful, slow, and humble. Good companions for the kind of storytelling we're doing together tonight. In the next part, we'll widen the map again, tracing Clovis across regions, west, plains, east, and southeast, to see how one horizon wears many local faces. If a technological horizon is a melody heard in many places at once, then each region adds its own harmony. Different tempos, different instruments, the same core refrain. Let's walk the late Pleistocene map and listen for those variations, keeping our steps soft and our claims careful. Begin in the interior west, where basins and ranges stage a geography of edges, wet to dry, low to high, spring to playa. Here, obsidian often speaks first. Its trace element signatures let us track movement with unusual clarity. Glass from one dome riding 100 kilometers in a biface. Another dome's glass joining it in a cache that implies rendezvous. In many Western assemblages, fluting runs long and straight, frequently single-sided, but sometimes paired, with basal grinding crisp and extensive. Overshot thinning scars are common on preforms and large bifaces, a sign of makers willing to take risk for speed and symmetry. Rock shelters harbor stacked occupations stitched by dripline sediments and slope wash. Open sites on fans and terraces preserve kill locales and short-stay camps sealed by overbank silts. Caches punctuate the story, packages of large early-stage bifaces and occasional finished points buried deliberately, some in exotic raw materials, some mixed, all suggesting planned mobility and place provisioning. In this dry, bright light, Clovis looks like a kit tuned for distance and repair, with teaching taking place at quarries where raw glass let apprentices make and break without starving the household of future edges. Step onto the high plains and adjoining parklands and feel the horizon widen. River valleys cut long lines across grass. Terraces offer stable ground and views. Aeolian mantles lay silt-like pages that turn and seal. Here, Clovis points are at home in big country, where bison, mammoth, and antelope set the schedule. Basal concavities tend to be moderate. Flutes range from short, serviceable channels to longer runs that reach halfway up the face. The famous choreography of kill and butchery is legible at several locales. Impact broken points near bone beds, resharpening flakes by butchered ribs, and the quiet geometry of marrow access written in percussion scars. The plains also carry long-distance stone, fine cherts and chalcedonies from uplifts and river gravels, curated through multiple resharpening lives, until a point is a slim survivor with many edges behind it. If the West's signature is glass and cash, the Plains is rhythm and reach, toolkits that bridge long legs of a seasonal round, supported by knowledge of crossings, winds, and where silt will kindly keep a floor for the future. Turn eastward into the woodlands and wet mosaics of the mid-continent and northeast. Forests were on the move at this time, but even as trees advanced, extensive ecotones, edges of wood and open, favored a mixed economy of large game hunting and broad-spectrum foraging. Clovis-like points here often show careful basal grinding that extends farther up the blade, an accommodation to hafts that might see more moisture and motion in wood-rich settings. Fluting varies. In some local traditions, channels are shorter and deep. In others, longer and slender, sometimes bidirectional. Raw materials shift toward high-quality cherts, jaspers, and chalcedonies from bedded formations, stones that break predictably but reward patience over dramatic overshots. Camps cluster on river terraces, at confluences, and near wetlands where mastodons browsed, and where peat and muck sometimes preserved wood, seeds, and the faint rings of hearths. The record includes rare ceremonial contexts, burials accompanied by artifacts and ochre, that add human gravity to a toolkit often seen through hunting alone. In the East, Clovis wears its elegance with a different texture, a hafting system tuned for damp, a blade maintenance schedule shaped by mixed prey and plant work, and river corridors that functioned as both highways and calendars. Slide down to the southeast and Florida Peninsula, and the medium itself changes. Lower sea levels made springs, sinkholes, and river runs magnets for life, and water did what it often does best: preserved. In submerged contexts, Clovis Age layers hold bones, wood fragments, and occasionally lithics in quiet sediments where oxygen is low and time moves slowly. Points in this region can be smaller and sometimes more variable in flute length, with basal grinding thorough and edges showing frequent resharpening. The settings, karst windows, spring vents, tannic rivers, produce assemblages where plant and animal traces linger alongside stone, and where underwater methods recover intact floors bracketed by pale sediments you can read like thin paper. Off the modern coast, broad shelves now drowned once hosted shorelines, lagoons, and estuaries. The record there is only beginning to open as underwater survey expands. For now, inland water bodies tell much of the story: repeated visits to stable springs, mixed faunas processed at the water's edge, and toolkits adapted to patchy visibility and wet transport. Across these regions, certain constants bind the horizon. Basal grinding is nearly universal, a simple, elegant answer to cutting lashings. Fluting is the signature, but it shows local dialects, long and confident where raw material and teaching converged, short and stout where stone was tougher or risk calculus stricter. Bifacial thinning to an even thin cross-section is everywhere, but the route there varies. Overshots frequent in some western sets, controlled alternate percussion and pressure more common where stones asked for finesse. Half polish and striations read the same book in many scripts. Bindings seated against dull stone, micromotion that leaves longitudinal polish in the join, adhesive ghosts where resin and gum once held. Mobility patterns align with geology and water. Where chemically distinct obsidians dot the land, PXRF maps show spokes emanating from domes and crossing at meeting places. Where cherts rule, petrography and quarry surveys show river-following movements and stepping stone provisioning. Caches appear in multiple provinces, suggesting a shared logic of planting potential in the ground for future selves. Carry kits remain compact everywhere, a handful of large bifaces, a suite of points at different life stages, abrading stones, billets and tines, adhesive packets, spare foreshafts bound tight to resist warping. The differences are in the weights given to elements, not in the grammar. The tempo of occupations also varies. In open country with episodic floods, a single, intense event may leave a sealed floor and a tight cluster of dates, a snapshot. In rock shelters and caves, stacked thin lenses, ash, trampled silt, dripline gravels, record many short visits stretched across centuries, each lens a few hours long, together a film. In submerged springs, the sediment writes a longer, slower story, with better preservation of organics but a narrower window onto tasks. You rarely find the wind's handwriting there, but you read the waters with clarity. There are outliers and edge cases, as there should be in any broad phenomenon. In some Western sites, fluted and unfluted lanceolate points occur together, provoking questions about function, identity, and timing. In some Eastern assemblages, tools that look Clovis-like in outline carry differences in flaking strategy or half-treatment that argue for regional branches rather than a single trunk. Some plains caches contain forms that look forward into successor traditions, even as other pieces anchor the classic Clovis look. These are not contradictions. They are the expected blur at boundaries when people borrow, teach, and adapt at different rates in different places. Hold the map in your mind now, not as counties and state lines, but as stone sources, water paths, wind corridors, and meeting grounds. The West's glass and caches, the plains' long lines and bone beds, the East's damp joins and terrace camps, the Southeast's springs and submerged floors. Together they draw a horizon that is both coherent and comfortably variable. The melody holds, a fluted half-optimized point at the center of a small, maintainable kit, moving with people who knew distance and planned for repair. In the next part, we'll step just before the flare of that melody, into the quieter, older pages where pre-Clovis evidence has accumulated in caves, on coasts now drowned, and in stratified valleys, to ask what was already underway when the flute arrived. Let's dim the lantern and step below the bright Clovis flare into rooms where the light is softer, caves, rock shelters, and drowned coasts. Hear the record whispers, and we have to listen with methods as much as with ears. The question is simple to ask and careful to answer. What, if anything, was already underway before fluted points crossed the map? Begin far south at a place where water kept wood alive. Monte Verde in southern Chile gave archaeology a gift. A waterlogged camp with stakes, cordage, chewed seaweed, plant remains, and stone artifacts in secure, low-energy sediments. The dates sit earlier than the classic Clovis window. Even the most skeptical voices, after decades of re-examination, now treat Monte Verde as a persuasive pre-Clovis occupation. Its toolkit is not the loud geometry of later fluting. It is expedient flakes, shaped pieces, and perishable technology that the Pete kindly remembered. The quiet lesson is that absence of dramatic points is not absence of people. Move north and east into caves and springs. In Florida's karst, Paige Ladson preserved a mastodon tusk with cut marks and associated artifacts in stratified, submerged deposits older than Clovis. Divers, working with grid lines and provenience reels, sampled carefully. Radiocarbon on short-lived materials bracketed the layer. The context is not cinematic, it is orderly. In Oregon's Paisley Caves, coprolites yielded dates and ancient DNA consistent with human origin prior to fluted horizons, though the field learned, through that very work, how strict contamination controls must be to carry such claims. In Idaho, Cooper's Ferry presented stratified lithics with modeled ages that nudge earlier than 13,000 BP. Patient excavation and Bayesian framing did the heavy lifting, not headlines. Cross to the mid-continent and northeast, and the names change. Meadowcroft Rock Shelter in Pennsylvania, with long, thin lenses and carefully excavated microstratigraphy. Cactus Hill in Virginia, with a buried sandy layer beneath a later Paleoindian component. Deborah L. Friedkin, Buttermilk Creek, and Galt in Texas, with dense lithic deposits many interpret as older than Clovis, though debates continue about formation processes and how to read long, laminated sequences of flakes. Each site has its dossiers of supporters and skeptics. Each has improved the discipline's expectations for reporting, micromorphology to diagnose mixing, multiple AMS dates with tight pre-treatments, detailed artifact photos in situ, and open models that others can rerun. There are bolder and more contentious claims. Bluefish Caves in Yukon has offered cut-marked bones argued to be much older than Clovis. Critics ask whether carnivore damage could mimic those marks, and whether contexts were fully secure. In central Mexico, a high cave produced lithics that some read as human, others as geogenic breakage. Sedimentary DNA and radiocarbon have been brought to bear, and debate has been vigorous. On an ancient playa in New Mexico, human footprints set in lake-edge sediments have been dated more earlier than Clovis by radiocarbon on plant matter. Subsequent work has sought independent checks on those dates using multiple fractions and cross-validation. Many researchers now consider the footprint chronology increasingly strong. Some urge continued replication. Our calm phrasing stays consistent. Promising, intensively studied, trending toward acceptance in some quarters, still tested. If we shift from rooms of limestone to shorelines now underwater, the picture complicates for honest reasons. At 13,000 BP, sea levels stood lower. The Pacific and Atlantic shelves were broader. River mouths lay far seaward of today's. A kelp highway hypothesis proposes that rich, predictable coastal ecologies could have supported early movement by watercraft along the Pacific Rim. If true, much of the earliest coastal record is simply gone to depth. Where uplift or chance preserved ancient terraces above present sea level, survey has begun to find lithics and paleo shorelines. Offshore work with sub-bottom profilers and coring is extending the search. But the bias remains. We read the inland echo of a coastal story and must resist concluding too much from what erosion chose to leave on our desks. What do pre-Clovis toolkits look like when they appear? Often small, flexible, and heavy on expedient flake tools. In some regions, far west and northwest, stemmed points and unfluted lanceolate forms show up in contexts modeled as older than classic Clovis. In others, cores and flakes dominate with little formal projectile technology preserved. Bone and antler tools, where they survive, complicate our stone-biased expectations. Awls, rods, and beveled pieces speak to osseous craft that could have supplied tips and barbs invisible in many sites. The overall impression is diversity. No single pre-Clovis type, but many local answers to tasks, some of which later converge in the fluted solution set. Dating and modeling have changed the conversation more than any one locality. Radiocarbon calibration curves are better constrained across the late Pleistocene. Pre-treatments are stricter. Bayesian approaches integrate many dates with the truths of layers. Claims once advanced on a lone old charcoal piece in ambiguous sediment now face a higher bar. Short-lived materials from secure features, brackets above and below, agreement indices that show the model isn't inventing order. Some pre-Clovis claims fail these tests and retreat to the maybe shelf. Others survive and strengthen. The direction of travel as a community has been toward a cautious acceptance that people were here earlier than the Clovis horizon, with regional timing that likely varies and pathways that were multiple. Cautions multiply and improve the picture. Bioturbation is not a footnote. Rodents, roots, and insects can shift small pieces across centimeters that matter. Erosion and slope wash can lay young over old or bring old into young. Distinguishing human flaking from thermal shatter or trampling requires robust experimental analogs and inter-observer checks. Protein and DNA identifications, when possible, must clear contamination mazes and report raw spectra and sequences for others to review. Summed probability curves across many dates tempt us with waves that might be sampling, intensity, or calibration quirks. Regional, context-specific models tell humbler, truer stories. Ethical frames are part of the method, not separable from it. Older layers are not more important than living relationships to land. Consultation with descendant communities has reshaped research design at several headline sites, setting sampling limits, defining research questions together, sharing custody of materials and data. The immediate effect is respect. The scientific effect is better, because more eyes and different priorities find different flaws and possibilities. What does a calm synthesis look like right now? Something like this. By the time fluted points appear broadly, people have already learned parts of the continent. Some followed interior routes that changed from steppe tundra to shrub tundra to grassland. Some likely moved along coasts rich in kelp forests and river mouths. Some mixed modes across generations. Their technologies were various, suited to local tasks and raw materials. Many left light footprints in places that preserve poorly. When fluting spreads, it is not a beginning, was a rapid standardization of one effective hunting interface, stone to shaft, adopted by many communities who were already here. The Clovis horizon is real and remarkable. Pre-Clovis presence is, in many regions, quietly persuasive, and the work continues. Offshore surveys aim at paleo shorelines. Cave projects refine micromorphology. Labs pursue peptide-level proteomics with tighter control controls. Models grow as new dates join old ones in transparent code. We should expect revision. Some early claims will fade, others will brighten. A few will move from outlier to anchor. Hold that layered picture as we turn, next, to the open questions, timelines, pathways, and purposes. And what kinds of data could narrow the ranges without pretending away the uncertainty that honest work always leaves on the table? In the next part, we'll sit with those uncertainties directly and outline what would resolve them and what may never be resolvable. Uncertainty is not an embarrassment, it is a map of where to look next. After walking the bright ground of fluted points and the dimmer floors beneath them, several questions remain, each with edges we can define and paths we can imagine toward better answers. Let's sit with them quietly, one by one, and note what evidence could narrow their ranges without pretending away the irreducible unknowns that deep time keeps. First, when exactly does the Clovis horizon begin and end in different regions? We have modeled windows, clusters of dates that, with stratigraphic priors, give likely spans, but the ranges overlap and the edges feather. In some interiors, starts look slightly earlier than along the Far East. In others, the difference is within error. Ends are a cascade rather than a cliff, merging into Folsom in parts of the West and into unfluted lanceolate and regionally named complexes elsewhere. What would sharpen this? More short-lived radiocarbon samples, seeds, twigs, from sealed features directly associated with Clovis activity, especially in regions currently represented by a few anchor sites. Transparent Bayesian models published with raw data and code, independent tie points such as well-dated tephras or varved lake sequences bracketing occupations. We can expect the credible intervals to remain intervals, not points, but we can narrow them. Second, which pathways brought people into and through the continent before the horizon, and how did those routes feed into the Clovis spread? The interior ice-free corridor and the Pacific coastal kelp highway are not mutually exclusive. Both likely mattered across centuries, with doorways opening and closing as climate and ecology shifted. The offshore record is the biggest missing chapter. What would help? Submerged landscape surveys that locate paleo shorelines, drowned river mouths, and terrace edges, followed by coring and, where justified, underwater excavation, seeded DNA and microfossil work from those cores to reconstruct kelp forests and estuarine productivity. Careful modeling that integrates isostatic rebound, local sea level histories, and least cost travel along ancient coasts. Inland, high-resolution paleoecology along the corridor, macro and micro-botanical data, insect remains, oxygen isotopes, can clarify when that route offered continuous resources rather than just bare ground. Even then, we may never know specific journeys. We will settle, properly, for plausible corridors and their timing. Third, why fluting and why then? We can articulate the mechanical advantages: secure, deep seating in a composite haft, standardized interfaces across 4 shafts, ease of repair under time pressure. But thinning by flute is a risky way to solve a problem that can be approached by beveling or by starting thinner. Was fluting primarily functional, secondarily social signaling, or was signaling we are the people who do the hard thing, a co-equal driver once the technique spread? What would help? More large, well-documented experimental data sets that measure failure rates, haft strength, and field repair speed across alternative thinning strategies. Ethnographically informed models of skill transmission, showing when risky techniques stabilize in teacher-apprentice networks, and regional comparisons of fluting intensity versus raw material constraints. Even with such work, intention is hard to fossilize. We will likely retain a layered answer, a functional core wrapped in social meaning. Fourth, how uniform was the social fabric behind a technological horizon this broad? Clovis people is rightly retired as a cultural label. Hands that learn the same stone choreography could belong to many languages, kin systems, and seasonal rounds. Yet the coherence of form hints at strong teaching ties and periodic gatherings. Did groups meet at predictable places to exchange spouses and stone, or did ideas diffuse down the line without much direct social fusion? What would help? Spatial network analyses that treat raw material flows as edges in social graphs. Higher resolution sourcing that can differentiate subdomes and beds to detect multi-source mixing at rendezvous. Site-level demographic proxies, household counts, hearth clustering, feature sizes that, with caution, hint at aggregation events. Even then, identity exceeds the reach of stone. We can model connectivity. We will not reconstruct ceremony from flake scars. Fifth, what tasks, beyond big game hunting, filled the Clovis day? Points dominate our imagination because they preserve. Camps whisper a wider life. Hide work, plant processing, small game netting, childcare, teaching. The balance matters for understanding why the horizon spreads and transforms. What would help? Finer mesh recovery and flotation at more sites to bring plant macro remains and tiny fauna into view. Systematic microwear and residue programs that sample not only points, but the whole kit. And taphonomic studies that model what tasks vanish preferentially in each environment so we can correct expectations. Even with better recovery, perishable technologies, nets, bags, cordage, will remain undersung. We can at best triangulate them from residues, wear, and context. Sixth, how did rapid climate variability, especially the onset of the younger dryas, interact with the horizon's timing and transformation? We are tempted by neat alignments. Cooling begins, forms change, prey shift. The record shows some coincidences and some lags. What would help? Regional syntheses that pair modeled occupation spans with high-resolution paleoclimate archives, lake varves, speleothems, ice core teleconnections, so we can test for synchronous responses versus staggered ones. Modeling of prey landscapes under different climate states to assess where a Haft-optimized DART system had the biggest advantage, and attention to local exceptions that keep us honest about generalizations. Causation will remain a cautious word. Correlation, even when tight, is not a verdict. Seventh, and threaded through all the others, how do we ask and answer these questions ethically? Many critical contexts involve human remains, sacred places, or living landscapes with ongoing stewardship. Destructive sampling for dating, proteomics, or DNA consumes what cannot be replaced. What helps is already known and steadily improving. Early, genuine consultation with descendant communities on research design, minimal, targeted sampling with full documentation, shared custody of data and materials, commitments to open publication of raw measurements and models, so others need not resample to replicate. Some answers will remain unpursued by choice because care takes precedence. That is not a scientific failure. It is a mature framing of what counts as a good question. What about the far edges? The claims of very early presence, the occasional bone with marks that divide experts, the footprints that push calendars. Here, the uncertainty is the point. We hold them in a promising but provisional box while laboratories and teams independent of the original work apply different methods. Some will strengthen and move into the consensus. Some will soften. A few will fade. The discipline's job is not to cheer or boo, but to maintain standards, share data, and keep curiosity from outrunning care. A last uncertainty is more human than technical. How to tell this story to ourselves without freezing it into new myths. Clovis first was elegant and wrong. Clovis among many is messier and, for now, truer. Future cores, models, and dives will edit even that sentence. The best we can do is narrate with hedges earned by method, likely modeled, with incredible intervals, consistent with refits, bracketed by short-lived samples, replicated across labs. This vocabulary may feel cautious to the ear, it is generous to the truth. What would resolve much of this, practically? Not a single discovery, but a pattern. More sites with intact floors, more short-lived dates tied to clear features, more submerged landscapes mapped and sampled, more whole assemblage wear and residue studies, more raw material sourcing tied to good spatial analyses, more open data so models can be rerun and improved. And through it all, more partnerships that place scientific curiosity inside living responsibilities. Set the questions down gently. They are not weights, they are handles. Each gives us a way to pick up the past without squeezing too hard. The points remain beautiful. The layers remain patient. The methods remain our careful bridge between them. In the next part, we'll step back into the world of hazard and habit, ice margins, flood pulses, and the behaviors they favor, to see how landscapes of risk shape choices in the Clovis toolkit. Risk in the late Pleistocene wasn't a villain in a story. It was the air in the lungs of every decision. Ice margins creaked to the north, rivers braided and changed their minds, winds could empty a plain of animals in a single afternoon, and meat, the difference between strength and weakness, moved on legs of its own. To understand why a fluted, Haft-optimized point spread as it did, we have to feel how risk arranged the day. Begin with ice. Not the heroic cliffs of postcards, but the lived effects. Colder nights, late frosts that pinched plant schedules, meltwater lakes whose outlets could flip with a season and redraw a valley's paths. Where the Laurentide and Cordilleran once pressed, soils were young and raw, vegetation advanced in pulses, leaving mosaics of forage that made herbivores restive and mobile. For hunters, this meant uncertainty first and last. You scouted not only for animals, but for tomorrow's wind on the ridge you cannot yet see. A toolkit that favors repair over replacement, foreshafts that shear, points that seat deep and can be re-edged many times. Turns climate's volatility into manageable maintenance rather than catastrophic loss. Water was a second teacher. Rivers at 13,000 BP braided, split, and rejoined. Crossing them asked for judgment about gravel bars strong enough to hold, channels shallow enough to wade, and banks that wouldn't shear away under weight. Camps on inner bends offered shelter from wind and a view of approach routes, but they also flirted with floods when an upstream ice dam let go or a sudden rain worked a fan loose. A habit emerges in the record. Terraces and leeward dune faces favored for the balance of visibility and safety. Hearths tucked where water would bury, not erode, their ash. Caches planted where floods would seal rather than scatter. Risk writes site selection, and site selection writes what survives. Game was risk incarnate because it made its own choices. Bison antiquus traveled with grass the way a shadow follows form. Mammoths braided their days between water and open ground. Mastodons kept to wood and wet. Each species delivered different dangers. Bison could be turned and funneled, but a misread wind or a late shout could turn the hunters instead. Mammoth demanded approach management. A wounded animal is a decision with tusks. Mastodon pulled you into low, treacherous ground where footing failed and visibility narrowed to reeds and alder. A composite weapon system with a replaceable joint answers all three, not perfectly but well. Break the expendable part, keep the backbone, the main shaft, and the throwing leverage intact. Replace the forepart quickly and try again while the herd still holds its shape. Wind is a character in these scenes. It carries scent, it betrays presence, it speaks across grass with a syntax animals read as fluently as we do smoke. Planning an approach is a wind problem solved with place memory. The notch in a ridge where afternoon breezes turn, the cane thicket that hisses as a warning if you push too hard, the lee of a boulder that lets you signal with a hand where a shout would shatter the pattern. A standardized haft lets quiet signals multiply. Everyone knows how a point sits, how a foreshaft slides home, how many spares ride the thong. You do not explain those things while watching a line of backs as wide as doors shift on the far terrace. Predators set a perimeter of consequence. Short-faced bear and lion patrol stories stitched into bone. Wolves and coyotes audit the margins of every kill. The cost of lingering is higher when your back becomes another animal's front. Butchery marks at Clovis age kills show efficiency learned under pressure. Hide opened with long, shallow cuts. Tendons detached at precise angles. Marrow accessed with practiced blows. Points snapped on impact are resharpened or repurposed. Failing that, a new point comes out of the kit with the same half geometry and bindings. Standardization is risk's friend. It shrinks the time between failure and function. Injury hangs over everything. A snapped tibia is not a plot twist, it's a winter. Communities hedge with redundancy. More hands trained to finish a point. Not just the dedicated napper, more than one person carrying billet and a broader, shared understanding of where caches lie if kits are lost in ford or storm. When archaeology finds multiple preforms in a single camp, or caches planted on routes that make sense from two directions, it is reading a safety plan. Teaching, too, is risk management. Children learn by degrees, first soft stone, then small billets, then preforms where a mistake costs less. The horizon spreads because the risk of losing method is greater than the risk of sharing it. Seasonality sharpens and softens risk in turn. Late winter thins fat on animals and on people. Tools must hold until the first fish runs and shoots break ground. Spring floods complicate movement, but gift river corridors with beached carcasses and driftwood for fuel. High summer trades hypothermia for heat stress, water scarcity, and shimmering mirage. Points ride more lightly then, but hides are thicker with insects and require different work at the edge. Autumn compresses time. The window for drying meat and stacking calories opens hand in hand with storms that will take racks down if you misread weather. Each season is a different argument for a portable, maintainable kit. Landscape cues become a curriculum in risk. A line of willows means shallow groundwater and the probability of boggy footing. A dust devil on the plains says convective wind and meat-drying trouble. Crane calls tell of wetlands full of protein, and of mud that will take a calf, and then a hunter if you forget the old rule about probing with a staff. In this world, even decisions about where to sleep have tool implications. A rock shelter bench spares fuel, but concentrates smoke. Smoke cures sinew and deters insects, but it also hides in pores of stone and can confuse future dates if charcoal moves in microlayers. What feels like domestic choice is also data in waiting. Not every risk is obvious. Scarcity of high-quality raw stone is a slow risk that pushes groups toward different strategies. Where good chert is far, large bifaces serve as traveling quarries. Where glass is nearby, atlatl darts fly with tips that can be made quickly, but shatter more readily. Both choices are rational. Both leave different failure signatures in the ground. Standardized halves let you swap between stones as you move across geologies. The interface stays familiar while the edge chemistry changes with the land. Social risk folds around all of this. Meetings at quarries and fish runs are chances to exchange material and mates, and to avoid conflicts with neighbors who share roots and water. A technology that signals competence without threatening identity. We do the hard thing with stone. You can trust our points. We do not require your tongue or ritual. Crosses boundaries more smoothly. Fluting is visible, teachable, and hard to fake. In risk arithmetic, that makes it powerful. You can read reliability in a glance at a stranger's kit. Dietary risk asks for breadth. Plant foods, fish, small game, insects. Each lowers variance in a schedule that cannot count on a mammoth today and tomorrow. The archaeological record remembers these better in some environments than others, where sieves and flotation recover seeds and tiny bones. Big game hunters turn into generalists with prowess in many directions. A point is the most visible part of a system that includes nets, bags, grindstones, cordage, and knowledge of when a plant's toxins can be leached. Risk mitigation is as much recipe as it is weapon. We sometimes imagine that a horizon ends because a better idea knocks on the door. Often horizons end because risk landscapes change. As the younger dryas cool snap strengthens or weakens by region, water routes alter, prey redistribute, and the cost-benefit math of fluting shifts. In some places, a deeper, narrower Folsom flute appears, another answer tuned to new prey and habits. Elsewhere, unfluted lanceolates hold the line, paired with hafting that solves the same interface in a different way. None of this needs a catastrophe. It needs only the steady slide of baselines and climate and social ties. Listen for a moment to the sound of risk being managed. A quiet conference at first light, breaths visible, as hands check bindings and make small corrections. A test flex of a dart, a forefinger run along a ground base to feel if grit has crept in, a glance to a teenager learning where to stand and how not to startle a line of backs, a shared nod toward a cache you will dig when the season turns. Risk is not an enemy. It is the frame that makes a standardized, repairable, elegant solution worth carrying across a continent. In the next part, we'll turn from landscapes to the people themselves, the lineages of skill, the teaching scenes at quarries and fires, and the traditions that let a risky technique become a shared inheritance. Imagine a circle of light on ground the color of ash. The fire is small because wind tonight is a listener. Sparks rise and vanish as if the sky were taking short breaths. Someone, an elder by experience if not by years, turns a biface in their hands the way a reader turns a page. The young sit where they can see wrists, not just results. This is a class without a chalkboard. The lesson plan is stone, time, and the patience to let failure arrive without shame. Teaching begins before tools. It begins with bodies arranged to see. The elder places the preform on a leather pad over one thigh, hips open, shoulders loose. They draw a thumb across an edge and say nothing. The students watch which way the nail catches, learning to feel platform angles through skin. The billet rises and falls with a soft, percussive heartbeat. Each flake releases a bright answer. The elder does not narrate like a book. They narrate like weather. A nod here, a pause there, a second tap to show that preparation is not delay, it is the work. Apprenticeships leave traces. On quarry benches where raw stone is generous, the ground records experiments, the short, shattered flute attempts, the overbold overshots that decapitate an edge, the clumsy platforms crushed by blows that tried to be strong before they were smart. Among these are pieces with corrections, edges re-straightened, hinges chased and erased, short flutes accepted as enough for the day. In the better debris, you can see a hand learning to tell the blank what it already wants to be. Communities do not pay this tuition when hunger is loud. They pay it at planned moments. After a successful hunt, during a rendezvous, by a spring when fish run and time swells. Skill has lineages. They are not written in surnames, but in flake scars, the length of a flute a grandparent favored, the way a parent ground basil corners a little higher for safety, the pressure flake cadence that a teenager copies perfectly and then one night improves. The horizon's coherence, fluting from the base, ground joins, elegant thinning, implies not only adoption but inheritance. Sequences preserved across camps, checked when groups meet, corrected gently in the kind of public that respects skill without making it spectacle. Who teaches? Anyone who can be trusted with a billet and with a student's confidence. Craft is not a single gender, age, or role. It is a capacity communities distribute for resilience. In some camps, you might see older men tuned to heavy percussion and younger ones learning, while women who have been curing hides since childhood carry the finest edge reading and pressure control in the camp. In others, the split is different. The archaeological record cannot assign identities to techniques. What it reveals is redundancy. Many hands able to finish a point, bind a haft, and diagnose a failure. That redundancy is a social choice as much as a technological one. It keeps a group from losing function when a single expert is hurt or away. Teaching also works at the scale of systems. A point only matters if haft, shaft, binding, and adhesive make a composite that lives. Someone shows a novice how to twist sinew so fibers lie flat and pull evenly, how to warm resin until it flows without burning, how to char a socket's mouth to harden its surface, how to lash so bindings bite into ground stone, and then, as they dry, tighten like weather. These are quiet lessons. They happen by lamplight while stories walk. They happen at noon when a dart fails and repair is a better teacher than pride. They happen at rivers with fish scales on fingers and resin flecks on palms. Ritual is not necessary for skill to persist, but ritual helps memory. A first flute that runs long may be marked with ochre and laughter. A cache may be planted with a small speech that pairs stone to place. A rendezvous may open with a demonstration where elders make the hard thing look easy so everyone remembers the standard. None of this makes the points sacred in a way that removes them from work. It makes work honorable in a way that resists carelessness. Trust rides on visible competence. When groups meet, drawn by migrations of bison or salmon, or by a quarry that knits valleys together, strangers read each other's kits the way sailors read rigging. A well-made point signals not only hunting success, but discipline. This camp knows how to prepare platforms before striking. This camp grinds bases so lashings last. This camp can afford to teach without starving. Exchange follows naturally. A bundle of glassy blanks goes one way. A recipe for resin tempered with just the right ash goes the other. Marriages are arranged with the same attention to balance. Children are present in this world everywhere, except in some archaeological reports. Their absence in the record is about preservation and bias, not about life. A small hand reaching to touch a dull ground base learns safe curiosity. A teenager tasked with scanning for wind while adults strike learns consequence. The first time an apprentice holds a preform for someone else's flute attempt, they learn how support is as much craft as striking. These lessons build communities that travel light and fix quickly, traits the horizon requires. Failure is a teacher with perfect recall. Points snap during fluting, on first impact, on third resharpening, when an old hinge awakens. Communities respond with norms. Accept the short flute, overbuild the base if the stone is glassy. Carry 2 extra foreshafts when crossing the basin that eats darts. Norms change with landscape. In damp woodlands, grind higher and use more adhesive. In dry glass country, favor pressure flaking that leaves strong margins. The horizon stays coherent not because it resists change, but because it changes intelligibly within a shared grammar. Ethical note: when we tell stories about the people behind the points, we are speaking about ancestors of living indigenous nations across the Americas. Their descendants carry languages, ceremonies, and knowledge that do not fossilize in stone. Research that touches burials, sacred places, or cherished landscapes should be shaped and governed with those nations as partners, deciding together what questions to ask, what to sample, and what to leave undisturbed. Respect is not only right, It makes the science better by widening the circle of expertise and care. What about roles beyond making and hunting? Hidework turns success into shelter and clothing. Plant knowledge turns seasons into steadiness. Fire keeps bindings honest and insects kind. Navigation remembers where the river shifts after storms. In many camps, the person with the best eye for weather might also be the one who takes the billet when an apprentice freezes. Specialization exists, but porous. Everyone carries more than one competence, because in a small group, redundancy is life. Teaching also holds the future in small ways. A child entrusted with an abroader stone is being handed more than a tool. They are being told, "You will keep us from cutting our lashings." An adolescent who is allowed to try a flute on a near-finished preform is being told, "We can afford your failure, which means we expect your success later." Communities invest in skill the way they invest in caches, planting potential along a route they plan to walk again. Hold one last scene. Evening near a quarry. The day's work lies in tidy stacks. Preforms wrapped in hides, a few finished points bound to foreshafts, billets hung to dry. In the near dark, someone places a broad biface into the ground, with a gesture that is both practical and ceremonial. Not a gift to the earth, so much as a promise to return. The child who watched will be older when that cache opens. When they do, the first touch on groundstone will feel like touching the past and the future at once. In the next part, we'll watch how climate jolts and social currents nudge traditions, how the Clovis melody modulates into successors like Folsom and Dalton, and how change can be both abrupt in artifacts and gradual in lives. Picture a camp at the shoulder of a season. The air tastes metallic, as if snow is thinking about itself. A river that ran clear last week now carries fine, slate-colored silt, and driftwood rides low, as if reluctant to choose a bank. Someone tests a binding with a thumbnail and frowns. It's not disaster, it's drift. But drift, repeated across years, becomes a bend in history. We sit close to the onset of the Younger Dryas now, around 12. 9,000 years ago in calibrated years, when many records register a quick step toward colder, drier conditions in some regions and a complex rearrangement in others. The pivotal truth is not a single temperature line, it's variability. Snowline climbs and falls by valleys. Lake outlets capture and then abandon channels. Plant communities pause or retreat in places, even as they press forward elsewhere. In such a world, decisions tighten. A technology thrives if it tolerates narrow windows, short hunts between gusts, quick repairs while clouds stack, reliable joins when fingers are stiff. Clovis sits on this hinge. Its composite weapon system, darts driven by atlatls, foreshafts that shear, fluted tips that seat deep and true, performs across conditions. But performance isn't the only pressure. Mobility calendars shift when pronghorn delay fawning or when bison routes detour around wind-scoured flats. River crossings change when an upstream ice-dammed lake drains through a new notch and leaves a sand braid where a gravel ford used to be. If your seasonal round was tuned to last year's ice shadows, you adapt, or you spend too many days moving your camp instead of filling it. The archaeological register of adaptation is subtle at first, then decisive. In parts of the interior West, the next horizon, Folsom, shows deeper, more exacting flutes on slender points that look as if breath itself could break them. Yet they are robust in their own way. Thin, straight, exquisitely haftable. Folsom's map overlaps with Lake Clovis, but the tempo differs. On the plains, where bison become the dominant large game after mammoths decline, narrower points with longer flutes paired with new half geometries may have offered advantages for penetrating rib cages at distance with lighter darts. In wooded and riverine east and southeast districts, Clovis modulates not always to Folsom, but to regionally inflected lanceolate forms, some with short flutes, some unfluted, paired to hafting practices that fit wetter, denser environments. Technological change is not a baton pass on a track, it's a confluence, tributaries crossing and complicating one another. Climate jolts don't act alone. Social networks breathe in and out with them. A bad winter in one drainage sends families to seek kin in another. Information travels with bodies. Teaching scenes move. A quarry that once served as a summer classroom becomes risky in windstorms. Instruction shifts to a lee-side bench near a spring. When and where groups meet to exchange mates and stone changes. That churn is fertile ground for innovation. A clever tweak to the nipple platform, or a more forgiving adhesive blend can leap farther in 3 seasons of turbulent rendezvous than in 10 seasons of calm. We should resist clean causation stories. Mammoth decline and the Younger Dryas have been placed side by side on many slides, as if one wrote the other. The timeline is tangled by region. In some places, mammoth and Clovis overlap comfortably. In others, mammoth bones grow rare just as points proliferate. Overhunting narratives, overkill, carry moral clarity but often oversimplify prey dynamics, reproduction rates, and habitat shifts. Climate-only narratives underplay the agency of hunters who could alter local pressures. The evidence best supports braided drivers, climate variability reorganizing habitats, prey communities shifting composition and abundance, people adjusting logistics, learning curves, and social ties, technology evolving within those constraints and freedoms. The river isn't carved by one flood, it's carved by many waters. Look at carry kits during these transitions, and you see different emphases. In regions trending drier and colder, with plains opening and bison aggregating seasonally, kits tilt toward redundancy in projectiles, more spare foreshafts, more preforms staged to finish into narrow points, more abroaders to keep joins honest in gritty wind. In districts where wetlands and rivers buffer climate shocks, springs stable in drought years, floodplains rich after pulses, kits show more diversity, scrapers adapted for thick hides and damp air, knives that trade a little penetration for durability in heavy plant work, expedient flakes struck from local cobbles, so curated bifaces can save their edges for hunts. Neither kit is better. Each is correct for a calendar. Caches also adjust. A cache planted on a terrace that floods unpredictably loses its utility. A cache tucked behind a bedrock rib above a spring becomes the new insurance. Some later Paleoindian caches include blanks that prefigure successor styles, slimmer preforms, different base geometries, hinting that makers hedge their bets, bury a package that can be finished forward into whatever point the next 2 winters demand. That is cultural agility expressed as geology in waiting. Risk management in pedagogy tightens too. If fluting failure rates cost more when good stone is scarce, or when travel windows shorten, instruction shifts toward techniques that lower variance without sacrificing function. We see, in some regions, a retreat from extravagant overshot thinning toward more controlled alternate phase percussion and pressure. In others, overshots persist where raw materials and teaching traditions keep the failure tax affordable. Folsom's long flutes look like an increase in risk. In practice, they may reflect mastery that makes hard things routine under new prey and dart dynamics. A culture can raise the floor of competence even as it raises the ceiling of difficulty. What about adhesives and bindings across a climatic bend? Resin behavior changes with temperature and humidity. A pitch blend perfect at 10 degrees can turn brittle at 5 degrees and gummy at 25 degrees and less tempered. Communities learn. More charcoal when cold snaps dominate. A touch more wax when heat flares. Plant gum blended in where conifers thin. Haft polish and residue chemistry hint that these recipes evolved locally while the overall haft interface, thinned, ground, clean seating, remained stable. The flute allowed recipe diversity behind a consistent joint geometry. There's also the quiet, cumulative pressure of demographics. If Clovis-age communities grew in some regions during favorable years, local raw materials would face more hands, quarries would be busier, novices would practice on edges that elders once reserved for perfect weather. More people means more innovation and more accidents. Variation in point form widens in such periods not because standards collapse, but because experiments multiply and regional house styles cohere as subnetworks of teachers develop reputations. The archaeological sign is subtle, slightly different shoulders, flute lengths, basal concavity depths clustering by drainage, and it reads like dialect in stone. As forms modulate, identity work continues. A standardized, visibly difficult technique remains a social glue in unsettled times. We still do this. We still are us. At the same time, borrowing accelerates under stress. A camp that had never tried a bidirectional flute adopts it after a shared hunt with neighbors who make it look inevitable. A group that favored glass learns a chert-friendly platform prep when storms keep them from a dome one fall. Change doesn't require conquest. It requires proximity and respect. Through all of this, stories adjust. A first successful hunt with a narrower point becomes a tale that calibrates expectations for adolescence. A winter saved by a cache becomes a cautionary proverb. Bury more than your pride. The narrative layer is not visible in the dirt, but its consequences are the extra foreshafts, the shift in where grinding stops on a base, the new habit of planting caches at both ends of a risky basin. If you listen for grief, you may hear it. Loss rides in transitions, routes that no longer work, elders who remember a riverbank that moved, a favorite quarry whose face slumped after a thaw and buried the easy ledge. Yet change also carries relief, a new pass that opens earlier each spring, a once dry seep that is now reliable, a style that makes darts truer for a new prey norm. Cultural change is not only coping, it is also opportunity exercised with care. Where does this leave the Clovis horizon? Still beautiful, still eloquent, now situated. Not as a lone star, but as a bright constellation within a sky that turns. It rises in conditions that reward portable, maintainable hunting systems. It shines through variability. It gives way in patterns that mirror prey, water, and social networks bending together. No single jolt ends it everywhere at once. Rather, many small thresholds are crossed in many places until, when we lay the points from different centuries side by side, we can trace a melody-changing key. In the next part, we'll walk that modulation directly, beyond Clovis into Folsom, Dalton, and other regional styles, to see what changed, what persisted, and what those choices say about people navigating new maps of ice, water, and game. Lay 3 points on a felt pad in good light. To the left, a late, well-kept Clovis, broad-shouldered, flute ending near mid-blade, base ground to a soft dullness, edges showing the quiet scallops of resharpening. In the middle, Folsom, slimmer, longer, its flute a precise channel that nearly kisses the tip from both faces, base concavity deeper, grinding crisp and high. To the right, a Dalton from the eastern woodlands, unfluted, lanceolate to leaf-shaped, often with a slightly expanding stem or shouldered base, and edges that tell of long lives as knives after their days as tips. 3 answers to the same family of problems. 3 dialects in a language learned under different skies. Begin with Folsom on the plains and in the interior west, a tradition modeled by many researchers to follow the classic Clovis window. The eye goes first to the flute, not just longer, but more exacting, often bidirectional, running close to the tip and leaving a wafer-thin median ridge. The cross-section is blade-like. Edges are straighter and thinner than most Clovis and the basal concavity deeper. This is not just style, it is engineering in another register. Many have read Folsom as tuned to bison hunting, under conditions where precision flight and deep, secure hafting into narrow sockets mattered. Kill locales with dense bison bone, drive features on terraces and in arroyos, and resharpening floors all support a shift in prey emphasis after mammoth grows rare. The atlatl dart system persists, but darts and foreshafts likely balance a bit lighter to take advantage of the svelte stone. Risk has not left the shed. It has been domesticated. Makers remove mass with controlled precision. Fluting is still dangerous, but feels less like a gamble and more like a rite you pass by training. The social fabric changes in tandem. Plains landscapes in the early Younger Dryas present aggregations of bison predictable enough to anchor large communal hunts. Those hunts are logistics machines: scouts, wind readers, pursuit teams, butchers, carriers, childcare, firekeepers. Folsom points join an organization that is as much choreography as craft. Caches persist, sometimes with preforms and blanks that look like promises for the next season. Raw materials keep traveling: plains cherts, Rocky Mountain obsidians, though the ratio of local to exotic can shift with route stability and meeting places. In the profile cuts, sealed floors show thin, repeated lenses, short, intense visits stitched into a centuries-long film. Now, slide east into the forests and river terraces where Dalton and related late Paleoindian, early archaic forms take the stage. Here, many assemblages trade fluting for other hafting strategies: stems, shoulders, basal thinning without a true flute. Dalton points, in particular, often display heavy resharpening, wide early in life, then progressively narrower, with tips re-established again and again until the tool dies as a drill bit or a graver. Dalton camps and kill butchery locales speak to a broader spectrum economy: deer prominent, fish and shellfish where rivers and estuaries permit, plant work better represented when recovery is fine and flotation thorough. The composite weapon system remains. The interface shifts. Instead of betting skill on a long flute, makers thin and grind the haft area, use stemmed geometry to stabilize the join, and invest more in blade length that can survive multiple resharpenings. It is a different answer to the same design brief. Secure, repairable, adaptable. Between these poles lies a suite of regional solutions. In parts of the mid-continent and southeast, short flutes persist for a time, Gainey, Barnes, Cumberland-like forms, each with distinctive basal treatments and flaking strategies, some favoring dramatic overshots on preforms, others preferring disciplined alternate face thinning. In the far west and Great Basin, unfluted lanceolate and stemmed points diversify alongside changing lake levels and wetland mosaics. Stemmed coast to interior traditions in the Pacific Northwest, and obsidian-rich basin sequences show communities matching haft style to shaft recipes, adhesive blends, and prey mixes that include fish runs and waterfowl as much as big terrestrial mammals. No single successor replaces Clovis everywhere. Technology branches along ecological and social lines. Functionally, several continuities bind these successors. Basal grinding, so simple, so effective, remains close to universal wherever bindings must survive friction. Composite construction persists. Foreshafts seat into main shafts. Resins and gums, often tempered with charcoal or mineral powder, hold stone to wood. Sinew or fiber bindings shrink dry to clamp joins. Microwear continues to show impact at tips, haft polish at bases, and the telltale rounding and step scarring of resharpening cycles. Residue chemistry still occasionally catches ghosts of animal proteins and adhesive recipes. The system works. What changes is the way mass is distributed in the stone and how the haft achieves security. Long flutes and deep concavities in Folsom, stems, shoulders, and robust basal thinning in Dalton and Kin. Chronology, spoken carefully, modeled sequences in multiple regions suggest that classic Folsom occupations begin after most Clovis activity, with overlaps in some drainages and handoffs in others. Dalton and allied traditions in the east and mid-south span the latest Pleistocene into the early Holocene, bridging climatic transitions with a kit that tolerates wetter forests and riverine mosaics. The numbers are ranges, not points. The overlaps are real and regionally variable. This is cultural evolution like a braided river, channels dividing and rejoining, rather than a single stream that turns all at once. Why these divergences? Partly prey, partly place, partly pedagogy. Where bison dominate and open country drives promise mass harvests, the returns to high precision, narrow, deeply fluted points paired with light darts may be strong. Where deer, fish, shellfish, and plants mix, a point that lives long as a knife after its throwing days is a better store of value. Where raw cherts are tough and glass is scarce, it makes sense to avoid the high breakage tax of long flutes and to invest in stemmed stability and generous blade length. Teaching traditions reinforce these choices. Once a camp masters a choreography, bidirectional fluting to near tip, or, alternatively, stout basal thinning with stems and shoulders, that choreography persists, modulates, and is elaborated in local house styles. Experimental replication keeps these comparisons honest. Kidnappers who can move between traditions report that Folsom-style thinning and fluting demand exquisite platform prep and support but yield intensely standardized haft zones. Dalton-style thinning with attention to stem geometry and basal beveling trades, some standardization in the join for robustness and huge repair potential in the blade. Field trials with replica darts suggest both systems can be highly effective. Differences emerge in breakage modes, repair speed, and how many resharpening episodes a tool can support before failure. In calm language, multiple optima, each rational in its niche. Caches and quarries continue as classrooms and banks. Some late Paleoindian caches include mixtures, preforms suited to multiple finishing pathways, evidence of hedge strategies and uncertain calendars. Quarry benched carry apprentice signatures in each tradition. Failed long flutes near Folsom workshops, crushed platforms and re-straightened edges in Dalton zones, where learning leaned toward edge management and basal geometry. The pedagogy is the same kindness delivered with different tools. Allow failure where stone is plentiful and meat is not at risk. Move hard steps into public demonstrations at rendezvous so the standard stays legible. A word about identity. It is tempting to read technological change as the movement of peoples. Sometimes it is. Often it is travel of methods across stable social fabrics. Descendant communities today hold diverse oral histories and relationships to places that cannot be resolved into point shapes. The ethical frame endures. Research proceeds best in partnership, with sampling minimized, data shared, and sacred contexts approached with consent and care. The stones we analyze are not only data, they are small intersections of past work and present responsibility. Set the 3 points back on the pad. Notice what did not change across the spread beyond Clovis. The value placed on secure joins, the habit of grinding where bindings lie, the expectation that tools must live through repair, the social decision to keep hard skills public enough to teach. Notice what did change, where risk sits in the manufacturing sequence. How much of it is front-loaded into a flute versus amortized across stem shaping and repeated edge maintenance. How blades either prioritize perfect flight today or promise many tomorrows of cutting. These are not better or worse choices. They are tuned instruments. A violin and a drum both keep time. They do it in voices the landscape and the calendar choose. When we speak of beyond Clovis, we are not narrating decline or triumph. We are listening to a melody modulate as water routes shift, prey calendars change, and teaching lines carry craft across gatherings where families eat, sing, argue, and plan. In the next part, we'll revisit myth versus evidence, testing popular claims, continent-wide overkill, single ice-free highway narratives, coast-only answers, against the broader record you and I have built together, and we'll let the data, not the drama, have the last word. Let's return, gently and without hurry, to 3 ideas that still travel widely outside the trenches and labs. That Clovis hunters swept a continent into silence, overkill. That a single ice-free highway delivered the first Americans like a parade, and that the coast alone carried all answers in canoes and kelp. Each story holds a shard of truth. Each, told too cleanly, bends the record past what careful layers permit. We'll set them on the table, turn them in the light, and keep what endures. Begin with overkill, the claim that specialized, efficient Clovis hunters, arriving to naive megafauna, quickly drove mammoth, mastodon, and many other large species to extinction. There is gravity here. Composite weapon, strategic hunts, and butchery skill are not in doubt. Neither is the late Pleistocene extinction pulse. But the timeline is not a single, sharp edge. Sure. Mammoth decline varies by region. Mastodon holds on longer in eastern wetlands than on open plains. Some large animals persist into early Holocene settings that postdate classic Clovis. When radiocarbon dates are modeled with stratigraphic order, the overlaps between humans and particular taxa look braided rather than stacked, sometimes tight, sometimes loose, rarely the crisp substitution that a pure overkill narrative prefers. Hunting pressure surely mattered locally. Drive lines, arroyo traps, and repeated visits to predictable crossings leave signatures that animals cannot ignore. Yet, climate variability sits beside these pressures, rearranging water, forage, and birth success in ways that amplify or dampen human effects. A colder snap pinches plant communities. A drought shifts herds toward risky bottlenecks. An outburst flood redraws valley routes. In such years, the same number of darts can fall heavier. The better phrasing, then, keeps agency plural, humans as one actor among many. Strong in some theaters, background in others, their impacts uneven and entangled with climate, habitat change, and the life histories of different species. Overkill as a continent-wide, rapid, single-cause story is too tidy. Targeted regional overpressure as part of a broader extinction mosaic remains plausible and likely. Next, the corridor. The image is familiar. 2 ice sheets, Laurentide and Cordilleran, draw back their shoulders, and an interior passage opens from the subarctic into the plains. People, the story goes, step through and spread. There is truth here too, especially late in the game. Geological and paleoecological records indicate that, by around the time Clovis technology flourishes in some interiors, parts of the corridor could sustain travelers, lakes stepping like stones, shrub tundra, and then grass-sedge mosaics, game moving in cautious recon. But open is not the same as welcoming, and the timing of ecological viability matters. For pre-Clovis presence in the far south, a purely corridor-first sequence strains under dates that point earlier or elsewhere. A better, calmer picture admits multiple doors at different times. The corridor works for some pulses, particularly as conditions improve. The Pacific margin works earlier for others, with kelp forests, estuaries, and river mouths offering a rich, predictable chain of resources and landing places. Interior shortcuts between basins, ice marginal routes along proglacial lakes, and later continental river highways all play parts. People are good at joining maps across generations. Pathways that start as seasonal experiments can harden into traditions. In short, the corridor is a chapter, not the prologue, and it likely shares the book with coastal and interior alternatives rather than erasing them. Now, the coast-only counter-myth, the pendulum swing that says watercraft and kelp forests explain everything, that interior signatures are late adopters at best. Here, submerged landscapes are the challenge and the temptation. With sea levels lower by tens of meters at 13,000 BP, many early shorelines are now offshore, their camps and middens sealed under silt. It is reasonable to expect we are missing pages. Ongoing offshore surveys, coring at paleo shorelines, and work on uplifted terraces have begun to recover hints of coastal life. But silence in our current sample is not a proof of prior dominance. It is a sampling bias we must correct with patience. The generous statement keeps both routes in play. Coastal travel is feasible, likely, and underrepresented in the preserved record. Interior dispersals also operated, at different times and scales, leaving clearer floors in some regions simply because rivers and terraces preserved them. A quiet thread ties these myths together, the seduction of single causes. We like doors, switches, and neat knots. Deep-time human stories usually offer braids, technologies that spread because they solved multiple problems at once, routes that open and close with climate pulses, prey communities that respond to predators, weather, and their own cycles in ways that are local before they are continental. The discipline's tools, radiocarbon with calibration, Bayesian models with stratigraphic priors, micromorphology to police mixing, sourcing to track mobility, microwear and residues to read tasks, push us toward complexity not because we prefer it, but because repeated measurements from many directions keep delivering it. Consider a composite scene that will not fit under one headline. On a proglacial lake's south rim, a Clovis Age camp repairs darts and teaches fluting to a teenager. Mammoth are rare here now, bison more common, dates from short-lived twigs in the hearth model to a window that brushes the younger Dryas onset. A month's walk west, an obsidian dome hosts a rendezvous where glass changes hands and a bidirectional flute technique is demonstrated to visitors from two drainages. Far downstream, on a river's drowned paleodelta, a small canoe slides out on a morning ebb with weirs that will catch fish on the flood. That camp's floors will slip beneath future waves. None of these episodes cancels the others. Together they describe how a horizon lives widely and ends as modulations rather than as silence. Ethical note, revisited. Extinction stories, corridor stories, coast stories, each brushes living identities. When we speak of firstness, arrival, or impact, we are speaking about ancestors of present indigenous nations, on lands where relationships to animals, water, and stone predate our terminology and persist beyond it. Good practice, co-designed research questions, minimal and transparent sampling, open data, shared stewardship, does not slow truth. It protects it from avoidable harm and widens the circle of what counts as evidence. So, what can we say, calmly and clearly, after the revisiting? Overkill as a sole cause? Unlikely. Human hunting as a significant regionally variable force within a suite of drivers? Supported. A single interior highway as the one path? No. Interior passages as important at certain times and places? Yes. The coast as the only answer? No. The coast as an early, promising, undersampled corridor? Yes. The continent, in other words, was learned by many paths, peopled by many schedules, and read with many tools. Clovis technology blooms within that larger learning, bright, coherent, and brief in calendar terms, because it solved a hard interface problem elegantly at a moment when repairable, standardized hunting tips had unusually wide value. What would keep our myths healthy, trimmed to evidence? 3 habits. First, insist on sequences, not slogans. Context, tied dates, modeled occupations, and explicit uncertainties. Second, widen the sample. Submerged coasts, undersieved camps, under-modeled regions. Third, keep partners at the table, descendant communities, local stewards, and early career researchers whose questions bend the light differently. Myths are not enemies, they are scaffolds for curiosity. We revise them not by scolding, but by replacing beams with better wood. As you breathe out, let the neat edges blur where they should. The continent's peopling is not a line, it is a delta. Fluted points are not an arrival, they are a flourish. Coast and corridor are not rivals, they are verses in a longer song. The pleasure for us is to keep listening until the chords resolve as far as they can without forcing them silent. In the next part, we'll turn toward tomorrow. What kinds of data and collaborations could most decisively sharpen this picture, from offshore mapping to peptide-level proteomics? And we'll set out a short field guide for how to read new claims when they appear. If the last century of work built the scaffolding, the next few decades can add stairs where today we climb by hand. None of what follows needs drama. It needs patience, partnership, and tools applied where they will change conclusions rather than merely decorate them. Think of this as a calm shopping list for clarity. What kinds of evidence could narrow the ranges around Clovis and pre-Clovis timelines, pathways, and purposes? And a small field guide for reading the next big claim without losing your footing. Begin where the record is quiet because water is loud, the continental shelves. Submerged landscape archaeology is not a wish. It is our most obvious missing chapter. Priority 1 is mapping ancient coastlines, river mouths, lagoons, and terraces now offshore. High-resolution bathymetry and sub-bottom profiling can pick out paleochannels and drowned deltas. Coring those targets recovers layered silts, peat lenses, and shell beds that hold microfossils, charcoal, and sedimentary DNA, cDNA. A good core, dated with multiple fractions and cross-checked against regional sea level curves and isostatic rebound models, can say when kelp forests thickened, when estuaries stabilized, and whether human signals, bits of charcoal in unusual abundance, toolstone microflakes, entered those systems early. Where cores argue people might have been here, targeted, minimally invasive underwater testing can follow. Success looks like a few secure localities, not hundreds. Enough to show that early coastal movement is not a speculation, but a layer we can read. Move from water to layers on land. We need more sealed floors with short-lived radiocarbon samples in direct modeled association with activity. That sounds simple. It isn't. It means walking past photogenic isolates to excavate dull, stratified terraces with discipline. Micromorphology to diagnose mixing. Redundant dating above and below features. Bayesian models published with raw code so others can rerun them, and a preference for twigs and seeds over long-lived wood. It means mesh sizes that catch tiny bones and plant macro remains, flotation that turns hunters only into households, and whole assemblage microware sampling rather than tool-by-tool cherry-picking. Modesty in method is power in inference. Chemistry and molecules can help, carefully. Proteomics at the peptide level, LC-MS-MS, offers a path beyond older, over-promising blood tests. When sampling is micro-targeted, blanks are run, and identifications rest on multiple taxon-specific peptides. Residues can tie tools to broad prey classes without claiming more than chemistry permits. Adhesive identification with FTIR and GCMS can distinguish conifer resins, plant gums, waxes, and temper recipes. Done across regions, such work could reveal teaching lineages in glue as clearly as in stone. Sedimentary DNA in features and floors, handled with cleanroom rigor and reported with raw reads and contamination controls, can sketch local ecologies and, sometimes, human presence without touching artifacts at all. None of these lines should travel alone. They matter most when they confirm what context and where already whisper. Sourcing will keep drawing maps. Portable XRF for Obsidian has matured into a robust, non-destructive routine, extending similar resolution to siliceous rocks with petrography, cathodoluminescence, and targeted geochemistry can push chert assignments from district toward bed. The result is not trivia. When a camp stone pulls strongly from two distant sources, it signals rendezvous. When caches blend sources from opposite sides of a range, it suggests planned aggregation. Layer those maps atop modeled occupation windows and paleoclimate, and you get corridors that are not slogans but testable paths. On the modeling side, the wish list is simple: transparency and replication. Publish raw radiocarbon data, pre-treatment notes, and stratigraphic priors. share the OXCal or BCal code, report agreement indices and outlier models, run sensitivity tests. What happens if we downweight this sample? If we change this boundary assumption? Summed probability distributions across regions can still be useful, but only when accompanied by discussions of sampling intensity and calibration wiggles that can paint phantoms. The cure for tidy stories remains the same. Show your work, invite others to break it, and count replication as success rather than threat. A quiet frontier sits in fracture mechanics and engineering. We have good qualitative reasons for fluting, secure hafts, standardized joins. But large comparative experimental datasets can turn good reasons into numbers. Measure failure rates, impact performance, and repair time across fluted, beveled, and unfluted thinned bases with standardized darts, media, and weather conditions. Vary adhesive recipes by temperature and humidity. Track how quickly a field repair returns a system to function. The goal is not to crown a winner, but to quantify trade-offs, so regional shifts from Clovis to Folsom or Dalton read as rational responses to prey, climate, and raw material rather than as stylistic whims. Now, the How to Read a Headline Guide, 6 questions to keep in your pocket. Context first. Is the artifact in primary position with described stratigraphy, micromorphology, and feature associations, or is it an isolate? Are provenience and recording methods reported in enough detail to be audited? Dates many, not one. Do radiocarbon samples bracket the layer with short-lived materials? Are they calibrated and modeled with stratigraphic priors? Are outlier analyses reported? If only a single date carries the argument, breathe and wait. Multi-proxy or monoproxy? Strong claims rest on converging lines. Lithics plus features plus dates plus wear, or lithics plus residues plus dates, or sediments plus paleoecology plus dates in the absence of artifacts. One glamorous number should not drag the whole story. Clean chemistry. For biomolecules, are extraction blanks, lab controls, and independent replicates reported? Are proteomic identifications based on multiple unique peptides? For adhesives, are spectra and reference libraries shared? If contamination controls are thin, value the enthusiasm, but keep your eyebrow up. Open data and code. Can others rerun the model, examine the spectra, reassign the source? If not, treat the claim as promising but provisional. Fit to the broader map. Does a new early date harmonize with nearby paleoecology, sea level history, and other sites? If it requires a reality that exists nowhere else, it might be a real outlier, or it might be a measurement asking for a second opinion. These habits won't drain the pleasure from discovery. They will deepen it by letting the claims that survive feel earned. Threaded through everything is the ethical frame. The past we study is the ancestry and heritage of living indigenous nations. Good work starts with partnership, co-designed questions, consent-based sampling, explicit limits on destructive analyses, community review before publication where appropriate, and shared custody of collections and data. It continues with capacity building, training students from descendant communities as excavators, analysts, and co-authors, and with long-term commitments that outlast a grant cycle. Sometimes the best science is the question not asked, or the sample not taken, because the cost to its relationships, sacred places, or rare materials is too high. That restraint is not a loss. It is a choice that keeps doors open for future work under better terms. Curation is part of ethics, too. Irreplaceable artifacts and samples deserve stable, climate-controlled homes and digital twins, high-resolution 3D models, photomicrographs of wear and sampled spots, archived code and spectra, so that future teams can re-examine without resampling. Open by default should be a norm for data, with sensitive information, exact locations of fragile sites, culturally restricted content, protected by agreement, rather than by secrecy born of habit. Finally, remember that settling it rarely means closing the book. It means moving claims from loud to likely, from likely to robust, and from robust to part of the furniture we dust, but do not question every day. For Clovis and its neighbors, that furniture is already solid in outline, a late Pleistocene technological horizon, fluted, haft-optimized, standardized, spreading widely for a few centuries across varied landscapes, pre-Clovis presences in multiple regions, successors tuned to new prey, place, and calendars. The open drawers hold pathway mixes, regional onsets and offsets, and the social logics that kept a risky technique reliable through teaching. Set the list down. It is not urgent, it is durable. Somewhere offshore, a drowned river mouth waits for a core. Somewhere inland, a terrace holds a floor under two quiet lenses of silt. In a lab, a peptide library grows one careful identification at a time. And in more projects, meetings begin with the people whose ancestors made and used the tools we study. That is the work that turns myth into measured story. In the last part, we'll step back from methods and maps and close gently with the human meaning of a fluted point in the palm, the weight of a solution carried across winters, and wish you a quiet night. Hold the point again, real or imagined, in the cradle of your hand. Notice how your palm makes a shallow bowl, as if it always knew how to keep a small thing safe. The base rests against the valley where the lifeline folds. The tip, even dulled by time, asks for a little space. It weighs almost nothing, and yet it carries winters and distances and a choreography of hands that learned, corrected, and taught. You could almost miss the flute at first glance. Then it catches the light and becomes a sentence. Thin me here, seat me deep, let me do my work, let me break where it costs least when the world pushes back. We have walked a long arc together, frosty plains, drowned shorelines, corridors that open like cautious doors, caves that held their breath for millennia. We have listened to layers and to numbers that refuse to be single numbers, dates becoming ranges, ranges becoming sequences. We have watched risk turn into design, a joint that can be repaired fast, a point that can be sharpened many times, a kit that can be carried far without carrying fear. We have kept our language calm where the evidence is still gathering, and precise where it is already strong. If you drifted now and then, washing dishes or easing towards sleep, know that the story waited and resumed without complaint. Deep time is patient with us. At the heart of the episode sits a simple, generous conclusion. Clovis was not first in the sense the old textbooks wanted. It was first in something else. The first continental chord we can hear clearly, played by many communities at once, recognized by its fluted join, and by the habits of repair and teaching that made that join reliable. Earlier pages exist, quiet, diverse, sometimes drowned, and later pages flower into new regional answers. Through all of it, the human constant is care. A point is an act of care extended into risk, a promise made to hunger, to children, to companions whose steps you know in the dark. If you imagine the making one last time, do it with your breath. Inhale to the preparation, a platform abraded until it is honest. Exhale to the strike or the push, a wave moving under stone like a thought passing cleanly through. Inhale to the binding warm by the coals. Exhale to the sinew tightening as it dries. Inhale to the approach in wind. Exhale to the throw, the dart flying a short story told at arm's length. Not every story ends well. Some points snap, some hunts fail, some seasons scrape thin, but the grammar holds. We keep what works and share it, because sharing lowers variance and kindness is efficient. There is an intimacy to standardization we rarely name. A flute cut by hands you will never meet makes your own repair faster. A ground base from a camp a valley away protects your lashings as if those strangers were thinking of you. When we call it a technological horizon, we are describing a social ethic in stone. Do the hard thing well enough that others can trust you from across a river. It is no wonder such a method spreads. We have also kept the ethical light on. These aren't just tools, they sit inside living ancestries. Good work pairs curiosity with consent. It takes only what must be taken and shares what can be shared. It admits that sometimes the right move is to stop. We are guests on landscapes where knowledge has deeper roots than our vocabularies. Partnership isn't a new add-on to archaeology. It is the old truth spoken plainly. The past is not a mine, it is a relationship. Perhaps the best way to end is to step back until the continents shrink and the points become small sparks in a wider dark. Then pull in close again, to a camp where laughter follows a long flute, to a quarry bench where a teenager finally feels the wave run true, to a riverside where someone plants a cache and says a few words that mean, "We will be back." And you can feel, if you let yourself, the steadying comfort of competence shared across generations. It is not romantic to say that skill is a kind of love. It is practical to notice that love, in the form of teaching, is how hard things survive. If you've been listening in the car, may the road now feel a little longer in a good way. The fields outside your window holding layers you cannot see but can imagine. If you were cooking, may the rhythm of your knife have found a cousin in the cadence of pressure flaking. If you were drifting towards sleep, may the world at 13,000 BP meet you in a gentle dream. Grass moving in long lines, cranes calling, a small fire cupped against the wind, and in your palm, a point that is both tool and story. We will keep reading the pages that water hid and silt preserved. Offshore maps will sharpen, cores will speak, models will be rerun with better priors. New partnerships will widen the circle of who asks and who answers. The melody will not become a slogan again if we can help it. We will trade tidy myths for careful sentences and find, to our surprise, that careful sentences are softer to sleep on. Before we part, a small request in the spirit of our brand. If this sort of slow, factual storytelling helps you rest or think, consider tapping like or subscribe. Tell me when and how you listen. Under lamplight, on a night drive, in a quiet kitchen. Timestamps sit in the description, so you can revisit any part without searching. And if there's a topic you would like us to hold next, another artifact, another horizon, leave a note. This is a long conversation. I'm grateful for your company in it. Set the point down now, lightly. Let your shoulders drop. Breathe in once, slow and even. Breathe out, a little longer. The stones do not hurry, neither do we. Stay curious, stay calm.